2017 पेपर 1। चलो सो मतलब जितना मैंने पढ़ा उस हिसाब से ये वाला पेपर इजी होना चाहिए, पर्टिकुलरली बिकॉज फर्स्ट का पेपर इजी था। एनीवे लेट्स स्टार्ट। ओके इफ 2x minus y plus 1 is a tangent, ये क्या है? सेक्शन कितना है? सेक्शन 3। ओके दैट्स व्हाट आई वांट, सेक्शन 1। अच्छा नहीं, पार्ट 3 सेक्शन 1, गॉट इट। हाँ ठीक है ना। 2x minus y plus 1 is equal to, और ये क्या है? सिंगल करेक्ट। 7 questions, 4 options, one or more than one. Okay, got it. 2x minus y plus 1 equal to 0 tangent to this hyperbola. So the following cannot be the sides of a right angle triangle. Okay, ये certain it's also basically आपने को a ढूंढना है, right? That's all you want to find. Okay, it's a tangent to this hyperbola, जो भी है. So yeah, okay, 2x minus y plus 1 equal to 0. Huh, okay. So like basically क्या y equal to 2x minus 1. So like slope वाला 2 है, just y equal to mx plus minus square root of a square की जगह just a square, of course m squared, and then minus b square होता है, और yeah in this case minus b square minus 16 I guess. yeah तो ये जो चीज है just minus, oh god, so just 1 is equal to a square कितना है अपना, a just don't know, m is just 4, so 4a square and then minus 16. I believe that's correct. So what do you get? 4a square equal to 17, or I mean that's what we think, right? Because c is just, so y equal to 2x plus 1. I mean it doesn't actually make a difference because yeah m अपना 2 रहेगा and this is like 1. Got it. This is, so 4a square equal to 17, a square equal to 17 upon 4. So which of these cannot be sides of a right angle triangle? Okay, so a square is 17 upon 4. Does this actually work? A square 4 and 1, is this correct? 17 upon 4 doesn't look correct to me because it's like just 1 over there. Y equal to 2x plus 1. That's weird. Usually because the y equal to mx plus or minus square root of b square m square. Yeah, and this is a square is just, you don't know, b square is negative 16. Yeah, m square is just, so 4 वहाँ पे आ जाएगा, which means like 1 equal to this. Okay, yeah. So a square is just 17 upon 4 it seems. ठीक है, so like 2a, okay, 2a का square करेंगे, 4a square is 17. Alright, 17. Okay, so the following cannot be a sides of triangle. Okay, ये नहीं इंटीजर आएगा इसमें, but that would be इसमें दो but इसमें एक ही करेक्ट चाहिए ना, one or more than one. Okay, it's like multiple sections. Okay, got it. So just a and b. First नहीं 37 है, is this 37th question. So question a and b, right? Or 2a का, okay, like what is this, 64 plus 1 or something. Okay, whatever. So 17 plus 1 is that help? So बड़ी side कौन सी होगी? It's just square root of 17 or something with 4 थोड़ा सा बड़ा है, which means okay 17 plus 1 is like 18. Is that equal to 64? No, it's not. So then ये C भी correct नहीं है. Okay, what about this guy? Yeah, it works. 16 plus 1 is 17. तो ये काम करता है, ये काम नहीं करता है, and these also don't work because yeah. Next question: if a chord which is not tangent of the hyperbola of this parabola has this equation, तो ये tangent नहीं है, it has this equation and midpoint h comma k, so it's a chord of this parabola y is equal to 4 16x. Okay, midpoint h comma k is the following is are the possible values of p, h and k, right? So you got it. This is like a chord of that guy. Okay, so इसका h comma k, got it. Just y equal to p minus 2x से put करो, what you get, or you will always put x is equal to p minus 2 upon y, right? 2x का square है ना, okay, or yeah, like y is equal to 8 times of 2x, which is p minus y, like okay, 8p minus 8y I believe. So you know y square plus 8p, sorry, plus 8y, okay, minus 8p equal to 0, which means ki y mid is just negative 4. Yeah, so k is just negative 4, so midpoint negative 4. Okay, right. And then because ये इस equation में बैठता है, you can kind of figure out कि x के लिए क्या होगा. Okay, so you got yeah, y mid is just negative 4, and okay, interesting. H comma k, h the following is our possible values of, oh shit, you won't actually do that, huh? That's kind of not good. This is h comma negative 4. Okay, this 2x plus y equal to that guy. So basically you know that p is equal to 2h plus y just negative 4. Okay, that's nice. So p is just 2h minus 4. ये चाहिए अपने को. That should happen. और क्या कर सकते हैं? Like you got the y value and it happens to be negative 4. Yeah, that's all you can say pretty much. Isn't that right? ठीक है ना? No big deal. So p equal to negative 2, h equal to 2. Does that work? Oh, it's like saying that 2h minus p equal to 4, right? Okay, so 2h कितना होगा? 4, 4 minus of p. Okay, that's not 4. Or, I mean, k should be negative 4 in any case. So, like the following are possible values. तो ये तो impossible है because k equal to negative 3 ले लिया इन लोगों ने. Yeah, it's gonna be like this thing. Sure, just 2x equal to this guy. Midpoint has to be just y coordinate negative 4. Okay, तो ये दोनों में से this doesn't satisfy because 2h minus p, right, doesn't work. What about this guy? So 2h is 6 minus of p is 2. Okay, so c works. So answer C. Next question, 38 done. Let this be the let not equal to x. Then which of the following points the function this is discontinuous, and which of the following points this function is discontinuous? Essentially less than or equal to x. Okay, x cosine of pi x plus floor function x. Okay, think about it. इसकी डिसकंटिन्यूटी कब होगी? इट्स लाइक इसके अंदर का डेरिवेटिव जो रहेगा या वेल दैट्स बट इसमें x प्लस सम काइंड ऑफ कांस्टेंट आएगा, राइट? सो एक पर्टिकुलर रीजन में इट्स जस्ट या इसमें नेगेटिव साइन आने वाला है एंड दैट साइन थिंग शुड नॉट बी जीरो ऑफ कोर्स. सो पाई रहेगा, दैट शुड नॉट बी इंटीजर. सो x इक्वल टू एनी काइंड ऑफ इंटीजर जो उसके पास में रहेगा, दैट वोंट वर्क बिकॉज़ इट्स लाइक अप्रोचिंग जीरो. सो वो डेरिवेटिव्स विल या wait, we just want to be discontinuous. तो डिफरेंशियल नहीं लिखनी है. ओके, सो x इक्वल टू नेगेटिव 1 पे डिसकंटिन्यूअस है क्या? नेगेटिव 1 के पहले इट्स जस्ट नेगेटिव 2 रहेगा. इट्स लाइक x प्लस 2 जो भी है, एंड देन इट्स अप्रोचिंग नेगेटिव 1, नेगेटिव 1 प्लस नेगेटिव 2 इट्स लाइक नेगेटिव 3 कोसाइन ऑफ नेगेटिव 3 पाई एंड यू नो नेगेटिव उसमें आएगा. ओके, व्हाटएवर, जस्ट नेगेटिव 1. वो x को भूल जाओ, जस्ट दिस बेसिकली दिस थिंग. 0 पे तो ये कंटीन्यूअस रहेगा, सो दैट्स नॉट द थिंग. सम इंटीजर, हाँ राइट. सो इंटीजर्स के पास में क्या होगा? It's like an even, it's like 1 और फिर ये change होता है. Yeah, because it changes by 1, right? यहाँ से यहाँ जाने पे this changes by 1, but this does not actually change. So negative 1, 1 and 2 all work. 39 का ACD. Next 40. That f be continuous function. So the following functions have okay the value 0 at some point in the interval 0 to 1. Okay, this is a continuous function. So the following functions okay have the value 0 at some point in the interval. Okay, right, in the interval 0 to 1. So f is going from all real numbers to just 0 and 1. Wait, but सिर्फ interval में some point in this interval though, that is weird. 0 to 1 में चाहिए. That is positive everywhere, right? Okay, so x power 9 minus f of x. So it's like an increasing function minus another function which may not be increasing after all. और ये चीज़ क्या है? Just so 0 to pi upon 2 minus x. Oh, okay. So in cosine 3, huh? It's positive throughout. So it's maximum at 0. At 0 is just negative integral. Okay, it's negative at that point. And at x is equal to, I don't know, 1. It's just 1 minus integration from 0 to pi upon 2. Okay. Okay, think about it. Or maybe just pi upon 2 पे सोचते हैं, राइट? ओके, इसका जो डेरिवेटिव लाइक 1 माइनस ये चीज, राइट? ओके, एंड देन नेगेटिव उसमें आएगा. लाइक दिस इज एन एवर इंक्रीजिंग फंक्शन इट सीम्स. ओके, इस रेंज में इंक्रीजिंग फंक्शन 0 टू पाई अपॉन 2 में एट 0 इज जस्ट नेगेटिव, एट पाई अपॉन 2 ये मर जाएगा जस्ट पॉजिटिव. सो देयर इज 1 पॉइंट एट लीस्ट, एग्जैक्टली एक्चुअली 1 पॉइंट है. सो बी इज गुड, 40 का बी. और ए है क्या? एक्स पावर 9 प्लस एफ ऑफ एक्स. I mean, okay. It's around 9. Like 0 to 1, which is it goes from 0 to 1, right? Of course. Okay, it's f of x. And that's also in 0 to 1. Is this like possible कि ये कभी भी 0 ना हो in that range? I mean, it could be. It could be अगर वो throughout positive है in 0 to 1 range. Yeah, so just keep this. But नहीं, इसको negative रखना है. Okay. अच्छा, इसका मिनिमम वैल्यू क्या रहेगी? 0. सो इट्स लाइक 1 ऑफ द, हाँ, इट हैज टू बी 0 एट सम. सो अच्छा, ये ओपन इंटरवल है. व्हाट इफ इट्स 1 एग्जैक्टली एट, या व्हाट इफ इट्स 1 एग्जैक्टली एट 1 एफ एक्स, देन 1 माइनस 1 0 हो जाएगा. ओके, तो वो एग्जैक्टली 1 पे 0 होगा, व्हिच मींस मे बी नॉट. सो दिस आई एम नॉट सो श्योर अबाउट. व्हाट अबाउट दिस गाय? ई बार एस माइनस ये चीज 0 पे क्या वैल्यू इसकी? इसका डेरिवेटिव क्या होगा? इसका डेरिवेटिव साइन ऑफ x, हाँ okay, like from 0 to 1 की अपन बात कर रहे हैं. God, think about it. Sign of 1 like positive because 1 pi upon change over here. So you know, okay, so this is actually ठीक है ना. So this is like a decreasing function, like ये increasing function is like negative of that guy. Okay, and e power x. X plus this guy. Okay, this is like an increasing function for sure. So x equal to 0 पे just f of 0 plus, yeah, like at 0 just, wait, this is a constant, isn't it? It's a constant. So f of x is some kind of constant. F of x is a positive constant. ये कभी 0 नहीं हो सकता. So A and C possibilities है. It's now 9. Some point 9 of course. Think it's like from 0 to 1 और ये भी कहीं ना कहीं 0 को 0 to 1 में है, right? Yes. Okay, it's like अगर वो स्टार्ट में नेगेटिव रहा एंड ओके व्हाट इफ इट्स लाइक नेगेटिव थ्रू आउट, एट मैक्स नेगेटिव 1 होगा एंड दैट मींस कि वो 1 पे तो एटलीस्ट हो जाएगा, बट ए इज नॉट, अपने को ओपन इंटरवल्स मिलने चाहिए. दैट्स रॉन्ग. e power x minus, okay, once again same kind of story कि we don't know for sure what happens. So c is also probably not correct. Which of the following are not the square of 3 by 3 matrix with real entries? ये है, ये square of 3 by 3, hey, it's like a diagonal matrix, isn't it? Of course. Real entries, no, okay, not possible, not possible. Okay, what about this guy? Means that it's weird. So determinant क्या होगा? So determinant just -1. Okay, that makes it just impossible. इसका determinant is +1. Maybe it's possible. I don't know. Okay, and इसका determinant is also negative. So B and D not possible. But then A and C शायद से. Can you actually figure out कि ये क्या होना चाहिए? What if it's just me? Something like that. Okay, so x change नहीं हो रहा, but like y z coordinates हमारा change हो रहा है. So it's negative of this guy and then negative of that guy. दो बार अप्लाई करने से complicated. Rotation matrix, right? Rotation matrix of y and z is just because, right? Like pi से तुम rotate कर रहे हो. So first तुम pi upon 2 से rotate करोगे, which is like saying कि हमारा जो y coordinate है that just converts to z coordinate. Okay, हमारा I hat that becomes, sorry, your y hat that becomes z hat and your z hat becomes negative y hat. हाँ ठीक है. So C is correct. C is correct. A is correct. Right? अच्छा, not a square. So B is wrong and T is wrong. मतलब कि वो correct. 41 का B. Next, 42, let A be x y real number such that A minus B equal to 1 and y not equal to 0. If a complex number x blah 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 satisfies this thing, then the following is what are possible values of z, values of x. X कहाँ पर है? X y real numbers such that this happens in complex numbers. Okay, imaginary of a z plus b upon, okay, z plus 1 is equal to y. Interesting. So the following is what are possible values of x. Any minus b 1, and that's all you're actually giving us. So like a equal to b plus 1, put that over there or something. B equal to a minus 1. So other time put just what do you get? Like a times of z minus 1, sorry, z plus 1, and then minus 1 upon z plus 1, right? Okay, so it's the imaginary part, but then it's like a minus 1 upon, and ye real numbers is the imaginary part of the it's like basically this thing that imaginary part of -1 upon z plus 1 is equal to y, right? Or yeah. So basically what, like -1 upon z plus 1, that's equal to iota y, and then let's just call it like alpha plus iota y. So just -1 upon x plus 1 plus iota y is equal to this thing, right? Alpha plus iota y. So this means oh, you just want the imaginary part of this guy. Okay, that works out. That works out. It's -1 is equal to, yeah, that must be of course. Right. What else would you think? Just वो तो मर गया because b equal to that a minus 1. So that cancels. Awesome. Just what? -1 is equal to alpha x, alpha times x plus 1 basically. और क्या आ रहा है? जब भी अल्फा आ रहा है that's kind of a complication जो भी, and फिर plus iota alpha y, और ये जैसे alpha times of x plus 1 plus iota y. That's probably not the best way of doing it. -1 is equal to real part क्या होगा इसमें? Alpha times x plus 1, yeah, that's the thing, and minus y, that's also the real part, or just plus iota times alpha y, yeah, and then plus y times x plus 1. right? Which means कि alpha is equal to y minus 1 upon x plus 1 and it's also equal to, because it was 0 हो जाएगा, which means that alpha is equal to negative of x plus 1, which means that 1 minus y is equal to x plus 1 का square, just yeah, so x plus 1, right? So the following are possible values of x. Oh, okay, it's like x plus 1. So square root of 1 minus y is equal to x plus 1 or plus minus 3. X is just equal to negative 1 plus minus square root of 1 minus y, which is y squared. Wait, are you sure? Oh yeah, it should be y squared because negative y square I guess. Yes, it's y square over there. And that's just y over there. Yeah, just 1 minus y square. So this works and no, okay, minus 3 A works and B works, I guess. Yeah, so A and B put Luca. 43. Let x, y be events such that probability of x equal to 1/3, probability of x given y equal to 1/2, probability of y given x equal to 2.5. Then you can do x given. This x, this thing is y. X की probability क्या है? 1/2. बड़ा लाना चाहिए. Just pen diagram मेरी x. This is y. Probability of x given y is this thing. Probability of y given x is 2.5. So that is probability of x is just, so like what? 2/15 is probability of x intersection y. Okay, probability of x कितनी है? 1/3. So that's like 5/15. So it's just what, 3/15 यहाँ पे बचा हुआ portion. And then probability of what, x given y दिया है just 1/2. So this is 2 like 4. नहीं, it's also just 2/15, right? Okay, so probability of y is 4/15. Yes, understood. So A is correct. और combined कितना, just 2 plus 3 plus like 4 plus 7, right? Just 8/15 बाहर था. Okay, so 43. Probability of y is 4/15. Yes, that's right. Probability of x dash given y. Given y. Just 2/15 upon 1/15, just 1/2. So B is correct. Or क्या, probability of x intersection y is 2/15, not 1/5. Probability of x union y is 7/15, which is also not 2.5. Next question. Okay, क्या है ये? Single digit integer type, whatever. For how many values of p the circle, this circle and the coordinate axis have exactly 3 common points? ये circle और coordinate axis have 3 common points. Wait. 3 common points. मतलब 3 जगह पे वो intersect कर रहा है coordinate axis को. But axis, wait. एक पर्टिकुलर लाइन एक सर्कल को कितने बार, या तो 2 या फिर 1 बार, राइट? सो एक्स कोऑर्डिनेट एक्सिस, ओके, तो भी एक कोऑर्डिनेट एक्सिस को 2 बार कट कर रही है एंड एक कोऑर्डिनेट एक्सिस टेंजेंट है. कोऑर्डिनेट, राइट, एग्जैक्टली 3 पॉइंट्स. सो राइट, व्हेन थिंक अबाउट इट, सेंटर कहाँ पर? यू जस्ट हैव टू राइट इट लाइक दैट. x plus 1 का स्क्वायर प्लस y plus 2 का स्क्वायर इज इक्वल टू p plus 1 plus 4, which is just p plus 5. That's our r squared thing. ठीक है ना? So just call it r squared for now. तो हमारा -1, -2 एक पॉइंट है एंड यू हैव टू -1, -2. एंड देन इसको तुम बड़ा कर रहे हो. दैट्स ओनली वन वे दैट दिस एक्चुअली वर्क्स, कि तुम्हारा हमारे y कोऑर्डिनेट एक्सिस को, राइट, इट्स एक्चुअली कटिंग इट एंड देन ये टच कर रहा है. सो योर, या दिस थिंग. So 2 is equal to your r, मतलब p is just 4 हो जाएगी, which means your p should be 1 necessarily. There's only one value that actually happens. Yeah, because otherwise you... Oh no, there's another value. जब कोई भी एक इंटरसेक्शन पॉइंट ओरिजिन रहेगा, so 0 एक पॉसिबिलिटी है, and yeah, right, at 0 it will be actually less though. Wait. Shit, it's -1. So -1 is ये, and then 0 पे बड़ा रहेगा. Got it. So -1 and 0, those are the only two possibilities it seems. इसके अलावा just gonna go up like, yeah, so दो possibilities. So 44 का आंसर 2. 43, sorry, 45. F real to real be a differential function such that this happens if g of x equal to this thing, limit x tends to 0 of g of x is equal to f of 0 equal to 0, f of 5.2 equal to 3, and f dash of 0 equal to 1. Okay, if g of x equal to this, integral from x to pi upon 2 f of f dash of x cosine, बहुत कुछ है इसमें. cosec x का okay, that's just cot x cosec x cot it, just that. So like it's just a derivative of f of x times cosec x square, right? Just f of x cosec x or f of x upon sin x, and it goes from what to what? Just x to 5.2, I believe. Yeah, okay, right. Um, and that's g of x. Taken f of 0 is equal to 0 f of 5.2. Taken that's the thing. For x belonging to 0 to 5.2, then limit x tends to 0 of uh, g of x. It is f of 5.2 कितना था 3, like 3 upon sine 5 is 3. 3 minus x equal to 0 पे is just f of 0 upon 0, which is also 0.0. So f dash of 0, yeah, f dash of x upon cosine x, which is like 1. तो ठीक है ना, f dash of x कितना है? Just 1 over there, right? Yeah, that should be doing it. So this gives us 2, right? So it's answer 2, 45. Next question, 46. For a real number alpha, if this system of linear equations has infinitely many solutions, then 1 plus alpha squared is equal to what? Okay, this system has infinitely many solutions. Like yeah, it's got b to me 0 करना है, उसका d to me 0 करना है, got it, whatever. 1 negative 1 1 जो भी. It's like 1 1 1 यहाँ पे, and it's like that's alpha over there, 1 alpha. It's like alpha squared. The alpha तुमने repeat किया, right? Another symmetric matrix it seems. I guess the best is just to do it by. ठीक है ना, first we'll just calculate ये क्या रहेगा. Wait, that's alpha over there, and so 2 alpha, huh? It's like alpha squared plus alpha plus 1. That's just going to be stupid if I do that. Subtract कर सकता हूँ ना मैं? Yeah, subtract that. Oh, it's like the supersymmetric matrix. जो right. मुझे उसका याद भी नहीं आ रहा. Like suppose तुम्हारा ऐसा रहता है. Whatever, just do the thing. Subtract it. So 1 minus alpha square, यहाँ पे alpha square minus 1. So alpha square minus 1 मैं common निकाल रहा हूँ. What do you get? Just negative 1. ये तो 0 हो जाएगा. This thing just becomes 1 alpha 1 alpha, and then यहाँ पे just alpha square alpha and 1. Awesome. So फिर इसको उधर ऐड कर सकता हूँ, like alpha square plus 1 हो जाएगा, or you could just subtract that. I mean, that's what I'm thinking about. Okay. Okay. It's like 1 over there. Probably use that somehow, right? Huh. Okay, whatever. Just calculate it now. Yeah, it's still weird though. Subtracting does something, unfortunately. What if I just add alpha times of that? Okay, try करो alpha square minus 1 is just what? Negative 1 0 1. We'll just get like वो मर गया, just 0 1 2 alpha, यहाँ पे 1 आएगा, यहाँ पे alpha आएगा. Okay, it's like alpha squared. Awesome. Okay. I mean, whatever, just calculate the thing. So yeah, what do you get? Or you just do that thing, actually 0 हो जाएगा. जो भी है, just negative 1 times ये चीज़, it's just 1 minus 2 alpha squared. Okay. और क्या? I mean, we want this to be 0, right? Okay. So, this is not going good. There's no other way though. You just have to do it. ठीक है, just negative 1 1 minus 2 alpha. फिर ये 0 होकर चला गया, just yeah, plus alpha square times ये डिटरमिनेंट just 0 minus 1, just negative 1 over, which is what? तो ये equal to 0 करना है अपने को, which means that either alpha square equal to 1 or that's negative over, just 1 minus alpha square equal to 0, which means okay, just not alpha equal to 1. So ठीक है ना, which means alpha equal to plus or minus 1. Okay, और क्या है? This experiment should be 0 1 alpha squared. Okay, you know what? Actually, let's take this 1 alpha squared alpha 1, and then 1 negative 1 1. Awesome. So once again, just subtract. Oh, it's not that easy anymore. Wait, no, it is actually. Subtract ये alpha मरेगा, just alpha square minus 1. Alpha square minus 1 common ले लिया. Either that is equal to 0, like alpha square equal to 1 होना चाहिए. Oh, okay, this is 0, then this will automatically be 0 anyway. Right. So alpha square should be 1. Okay, yeah, okay. You just क्या जगह? Then this thing is what? Wait, but multiple things over there. Either it's like plus 1 or minus 1. That doesn't make any sense because that's not really just subtract and stuff. Alpha square has to be 1, right? For a real number alpha. I mean, yeah. So that is the thing, alpha squared must be 1. Right? So alpha equal to plus minus 1. And then choose that factor over there. Something else, something missing. Okay, let's write like this thing. Alpha 1 alpha, फिर यहाँ पे just 1 आ जाएगा. Then this is like alpha over there. This is 1. यहाँ पे just 1 negative 1 1. It should be equal to 0. जो भी है. Okay. just add these two of them, alpha plus 1 बाहर निकालता है, तो just basically this thing 1 1 1 1 alpha 1 1 negative 1 1, right? So cancel out some stuff. हाँ तो वही अपने आप जीरो ही हो रहा है, right? I mean alpha square equal to 1, that guarantees this will be zero anyway. So फिर ठीक है ना, that is the thing. Then but फिर अल्फा की दो पॉसिबिलिटीज है ना, infinitely many solutions. डिटरमिनेंट जीरो किया अपन ने, इसका डिटरमिनेंट भी अपन जीरो कर दिया देन. Okay, well, think about it. What if alpha equal to 1? It just becomes what? ये चीज 1 1 1 चाहिए हर जगह पे. So it's saying x plus y plus z equal to 1, and that's x plus y plus z equal to negative 1. That doesn't actually make any sense. Yeah, that's not going to work. So negative 1 put करना पड़ेगा, right? Okay, it's like x minus y plus, okay, negative x plus. Right, so alpha should just be negative 1. तो ये चीज क्या होगी? 1 minus 1 गया, just 1. 46 आंसर 1 होगा. Next 47. Word of length 10 formed using these letters. Let x be the number of such words where no letter is repeated. Let y be the number of such words where exactly one letter is repeated twice and no letter is repeated. And y upon 9x will do. Length 10 formed using letters. Okay. Number of words such that no letter is repeated. No letter is repeated such that, okay, मैं 10 words को use करके ठीक है ना. तो ये तुमने 10 तक लिया है, ओके. एंड y भी था, तो इसका या x इक्वल टू 10 फैक्टोरियल, और क्या है y इज इक्वल टू y the number of such words where exactly one letter is repeated twice and no other is repeated. Suppose तुमने कितने रिपीटेशन तुम, ओके इट्स लाइक 10, जो भी तुम रिपीट कर रहे हो यू हैव टू पुट दैट समवेयर. सो उसके लिए तुम्हारे पास दो चीज, इट्स लाइक 10c2, एंड जो बचे हुए 9 रहेंगे, जस्ट वांट परम्यूट देम, राइट, और समथिंग. या that looks correct. Just 10 times 10c2 times 2 bache हुए, just right. So each of them has like 9 रहेगा इसमें. Then first one has 9, just okay, 9 times 8 times, and okay 9 times 8 times चलते जाओ, right, because like 10 p 9 of course, upon 1 factorial. Oh, somehow वो still 10 factorial है. That is kind of weird. Okay, I mean it's still 10 factorial because yeah, I guess वो permutation फर्क नहीं पड़ता, that's why. Okay, cool. I mean, okay. So what do you want? Y upon x पहले तो y upon x is just 10 times 10c2, I believe. Okay, right. One letter is repeated twice and another is repeated. Just 10 factorial 1 second first. नहीं रे, 8 बचे रहेंगे, not 10. So you want to permute these 9 guys into 8 pockets, right? Okay, awesome. So just 8p9, okay, sorry, 9p8, right? 9p8. Just like 9 factorial upon 1 factorial, which is just 9 factorial turns out to be. Yes, that makes sense, right? So just you want y upon x, which is so 9 factorial, so 10 factorial. वो नीचे 10 आ जाएगा, okay. Okay, so 10 times of this guy, just okay. Understanding it. Yeah, it is 10c2. So you want what? You want by 9. It's like 10 times 9 upon 2, and that divided by 9. Just 5. So puts in concept 5. 48. Sides of a right angle triangle are in the progression. If triangle has area, this thing, what is the length of its smallest side? If a right angle triangle has progression, triangle has area 24. What is the length of its smallest side? So बड़ी साइड like a plus d रहेगी. हाँ ठीक है ना, smallest side. मिडल को अपन a बोल देते हैं. This will be a minus d over there, and then this is like a plus d. So what you have is just a plus d का square, like a square plus 2ad plus d square. And और क्या बोला है? एरिया दिया है. हाँ, we'll figure that out soon. Equal to what? A square plus इसका square, just a square minus 2ad plus d square. So guess what? ये cancel हो गया. Okay, awesome. Which is what? 4ad is equal to a square. So either a equal to 0, which makes no sense, or you just have 4d equal to a. Right, it's like d equal to a upon 4. जो भी है, that's one thing. And also area, just right, a square minus d squared is equal to 4 times 24, which is 8, and then you got 96, right? Yeah. So because a is just 4d, it becomes like 16 minus 1, just 15. D square is equal to 96. So you got d at least. That looks about right. Okay, so just d square equal to 96 upon. अपने करना कैसे? What is the length of its smallest side? Basically a minus t अपने को ढूंढना है somehow. Okay. Oof. Okay, like D is just this guy. Or you could say, okay, let's just like 4 minutes. This 3D is what you want to figure out. Hmm. Well, D square is just 96 upon 15, and then it's a square root. That's just not going to work. Oh, it's like 3 का multiple, नीचे 5 आ रहा है. But इसमें 5 आएगा यार. Largest side understood, but then smallest side. I mean, A is just 4D though. So, that should be 3D. That is A square minus D square. Oh, 2 times of that, not 4 times of that. So, just 48. Awesome. तो यहाँ पे just 15 D square equal to 48 होगा. Still not good. 15 तो still आएगा ही. बस. तो 3D चाहिए somehow. But then ये तो this won't work. It just won't work, right? Oh, it just won't. अपने को 3D चाहिए. Ah. Oh shit. Smallest side. Okay. This and that. Space for minus 8. Okay, got it. So you just had 3D. This thing is 4D. So just got 12D square upon to that 60 square. 60 square is equal to कितना दिया तुमने? 24. So D square is equal to 4. D equal to 2. Got it. Got it. Got it. Smallest size like 3 is 6. Okay. 48. Next question. 49. 49 is next questions of matching time. जो भी है मैट्रिक्स मैच ठीक है. Okay. These conics equations of tangent is equation of tangent to the conic and then point of contact respectively. Okay. X square plus a, okay, y square equal to a square. What's the equation of tangent, right? I mean, yeah, y equal to mx plus, you think it's y equal to mx plus a upon m. No, that's what the parabola. So, okay. Tangent is drawn to the suitable conic at the point of contact negative 1 comma 1. If the following is correct, only correct combination of the okay. Wait, what? Doesn't matter कि a क्या है? Okay, and at the point of contact negative 1 comma 1. Yeah, it doesn't actually matter. ठीक है ना? Just let's see first का 1. No, that just fails already. Then you got p. I mean, okay, the slope could have this negative 1. Slope is in fact 1 though. So, ठीक है, I mean, if slope is 1, then just got y equal to x plus a. Y equal to x plus square root of 2. Not that bad, honestly. Right? But e is bad tani, right? So that doesn't work. Whatever. Just a square of m square plus 1. That's for the circle. So first cancel 2 चाहिए probably. First cancel 2 and then you want what? Also the, right, just negative ma upon square of m square plus 1 comma a upon m square plus 1. This is for the parabola. And then first का 2 अपने को 2 चाहिए रहेगा. So I think q, okay, first 2 then q negative ma upon square of, but then it's just tangent over there. So just yeah. Got it. Just negative sin theta cosine theta times a कर रहे हो तुम, right? Which makes sense. Sin theta is this guy. Sure. So q is correct. मतलब कि first, okay. So b is right. 49 का b. और क्या है? 50 का है तो tangent. The suitable conic is found to be y equal to x plus 8 and its point of contact is this thing. And so the following options is the only correct combination. Okay, 8, 16. Tangent is y equal to x plus 8 and its point of contact. फर्क क्या पड़ता है, right? So 1 का 2 so only correct combination, ठीक है ना? First का 2 है क्या? No. Second का 4 it's an ellipse over there, x square upon a square plus y square upon, yeah, okay, so 4 looks correct. And then r, okay, 4 and then r, which is this thing, negative a square m square upon blah blah blah, whatever. Yeah, I mean that does look correct though, because at that point, अच्छा इसको अगर अपन इस पे पुट करते हैं, कहाँ पे मर गया ये, right? A square कटेगा जैसे, and then all you get is like उधर मरेगा, is just basically negative mx plus y is equal to, yeah, square root of all that stuff, right? So I guess you could say this works. Okay, second का 4 and then this is r. Yeah, I guess so. Wait, it's like m equal to plus 1 and then पर उसमें दो choices रहेगी ना, m equal to 1 or negative. Shit. Shit. Okay, we should still check. So negative 1 comma 1. Okay. And a equal to square root of 2. The following is correct. Uh-oh. So इसका क्या है? This negative x plus y is equal to a is not okay, not 2, right? That's the thing. और for अपन ने क्या किया, first का second का q. Okay, so ये जो चीज़ है y equal to m is just 1. Okay, yeah, it does work out. It works. Okay, plus square root of, yes, so plus में it works out. और ये क्या है? Once again, the only possibility is that second, fourth r, huh? Looks about right. Second, fourth r, just try it out. I'm able to x plus 8. Once again हमारा पॉजिटिव आ रहा है इसमें, so that's awesome. पॉइंट ऑफ कॉन्टैक्ट हमारा पॉजिटिव दिया हुआ है, यहाँ पे तो नेगेटिव दिया लेकिन, राइट? आई मीन दिस इज जस्ट नेगेटिव. हमारा स्लोप तो 1 है एंड दिस शुड, हाँ, वाज अनएक्सपेक्टेड. पॉइंट ऑफ कॉन्टैक्ट इज दिस गाय though, बट पॉइंट ऑफ कॉन्टैक्ट में ये दिया हुआ है, इट शुड बी पॉजिटिव, राइट? इट शुड बी पॉजिटिव. 8, बट ये पॉजिटिव है, दैट वुड मीन कि दिस इज नॉट गोइंग टू वर्क. ये पॉजिटिव समवेयर. ओके, p शायद से, ओके, मे बी. So m is just 1, so and a is positive, I guess, possibly, yes. तो ठीक है ना फिर. I guess the only way is like e चाहिए रहेगा अपने को, which means that maybe c is correct. इसका c देखते हैं. c is third, first and p. So third is this thing y is equal to 4x. इस केस में क्या है? इस केस में just y equal to, okay, 8, right? So अपना जो a रहेगा like a upon m. Oh, God, 8. A equal to 8 in this case. Okay. M equal to 1. Parabola, you just have y is equal to 4x, whatever. Point of contact is this thing, 8 comma 16. X square upon a upon m square try that, just 8 upon 1, just 8. And it's like 16 upon, oh, this somehow works out. So yeah, this actually works out, huh? Third, first, and p. So that's right. Third, first, p. Which is 50, but third, first, p is C. Next question, 51. Tangent to the suitable conic, column 1 at 3, so 3 comma 1 upon this not of this guy. The following is correct combination. So ये positive है सब कुछ. Okay. Slope तुम्हारा negative है. M is just negative square 3 upon 2. Okay. And then ये C वाली चीज positive है, which is okay, that's guaranteed. और points of contact हमारे दोनों positive है, which means पर M negative है, so it should be one of these guys, right? Because ये तो positive हो जाएगा. Oh, that's still positive, and this is still positive, huh? But ये negative होगा, right? Because either way, yeah. So this must be positive. तो ये काम कर सकता है, ये काम कर सकता है, ये नहीं काम कर सकता है. So that means कि yeah, probably one of these guys, Q or R. ठीक है, इसका following is correct. It could Q और R कहाँ पर है? इसमें कहीं भी Q नहीं है. So R की इसमें देखो. For R, just have ये किस लिए है? Ellipse के लिए, right? Yeah. But let's just have this thing, second R, right? Second, third R, second, fourth R for some reason. Oh, okay, that's ellipse. Sorry, second, fourth R. That looks about right. So D. 51 का D, right? Yeah. Whatever. Next question. Right. क्या दिया है? Column 1 contains information about zeros of f(x), f dash of x, f double dash of x. Column 2 contains information about the limiting behavior of f(x). जो भी है, at infinity contains information about the increasing decreasing nature of f of x. f(x) is this thing, x plus natural log of x. f is equal to x plus natural log x minus x natural log of x. X is just positive. Okay. We करना क्या? What do you want to figure out? f(x) is equal to 0 for some. Just figure out f dash. F dash is cut to 1 plus 1 upon x फिर minus natural log of x, and then you have minus 1. ये तो गया. Just 1 upon x minus natural log of x. Okay. What's f double dash? It's negative 1 minus 1. Alright. Minus 1 upon x. So ठीक है ना? F double dash is like negative everywhere. Okay. So f(x) equal to 0 for some x belonging to 1 to e square. करेक्ट कॉम्बिनेशन करेक्ट। अच्छा ये इनकरेक्ट था, लास्ट में भी कहीं इनकरेक्ट वगैरह दिया था क्या? नहीं, सारे करेक्ट ही थे। ओके, सो फॉलोइंग इज द करेक्ट कॉम्बिनेशन। एफ एक्स इक्वल टू जीरो फॉर सम एक्स बिलोंगिंग टू 1 to 2। उसमें कोई आर्बिट्री चॉइसेस तो नहीं है। इज दिस करेक्ट? इट्स जीरो फॉर सम एक्स बिलोंगिंग टू 1 to e square। ओके, well at 1, wait, first of all, इसका डेरिवेटिव क्या है? जस्ट दिस थिंग, राइट। second derivative is here negative and throughout. So 1 पे is just 1 minus something like that's positive, and then e squared पे is just 1 upon e minus 2, which happens to be negative. Right, so it's got f dash is drops is like positive at some points and negative at some points. But that means key at e just like, okay, what? This is not going to work. X is equal to just what x power x is equal to 0 or something like that. X power x should be, so it's at 1. At 1, तुम्हारा, oh, okay, so like at 1 this will just be 0. Wait, no, just, no, that's not the right thing to do. It's about x. 1 is equal to, 1 equal to x is equal to x, like x of x power x equal to 1, so that x power x should be equal to e. When does that happen? I don't know. So तब maximum minimum क्या आंसर हो सकते हैं? कि ठीक है, f x equal to 0 for some x belong to 1 to e square. Like at 1 it's what? The 1 is just 1 minus, this is not going to help. We can get here 1 1 blah blah. Okay, when x tends to infinity, okay, at least ये तो अपन निकाल सकते हैं. So x tends to infinity, what is f of x, right? Yeah, so x tends to infinity, तुम्हारा look, तुम्हारा f double dash is like negative, so as x increases eventually तुम्हारा f dash negative हो जाएगा, right? I mean what sure is like bigger and, तो वो, right, it's negative, it's like always going to decrease. Okay, so it's going to decrease जो भी है. With x tends to infinity, what does this become? X plus log of x minus plus log of x. Okay, it's like what? X plus 1 minus x plus log of x. Or this thing, x times 1 minus plus log of x plus plus log of x. This is so stupid, right? Exactly. This is approaching negative infinity. This is approaching infinity. Okay, this is not going good. This complete thing. It's like the sequence of this guy, right? Well, you know the am is bigger than, okay, that you could use probably. So मैं इसमें negative 1 put कर सकता हूँ. Just what will this become? It just becomes negative 1, or actually 1 minus, because yeah, okay, 1 minus of x minus 1 natural log of x minus 1. So, oh yeah, it just approaches negative infinity. That does it. So yes, it does approach negative infinity. Okay, तो कहाँ पे था मैं इसे? Right, x tends to infinity is negative infinity. So that, right, second तो correct है, जहाँ भी second है वो correct होगा. X tends to infinity of f(x) is equal to 0. No, it's not. So second अपने को चाहिए रहेगा, और क्या है? x tends to infinity f dash of x. Just ये तो मर गया, just negative infinity. That also pushes negative infinity. So second is correct, third is correct. Then x tends to infinity f double dash of x is equal to 0. F double dash. Yes, okay. So fourth is also correct. Second, third, fourth. सही है. So ये तो incorrect हो गया in that case. और इसमें कुछ ऐसा है क्या? हाँ, right. As I thought, इसमें first है. So look at that. 54 का C. Got that. और क्या? 53. So the following is the only correct combination. ये तो फर्स्ट इसमें आ रहा है, फर्स्ट आ रहा है, वो गया. और अबाउट दिस गाय, f is increasing 0 to 1. This f increasing 0 to 1. F dash is just this thing. So at 0 it's like infinity, so it's positive. And at 1 it's the first time कि ये, अच्छा नहीं, at 1 it's just 1 minus natural log. Okay, that's still positive. So throughout it was still positive. Yes, it is increasing. So P correct होगा. Okay, Q, f is decreasing in e to e square. So f dash is actually negative. That's what we're saying. Into e square. And e is just 1 upon e minus 1, which happens to be negative. Yes, and then after that will be negative, right? Throughout. Yes. Because इसका derivative just negative हो गया. Okay, so yes, it's just decreasing into e square. So P is correct, Q is correct. F dash is increasing in 0 to 1. F dash. 0 to 1 में ये चीज क्या है? I mean it's decreasing throughout. So okay, R गलत होगा, जहाँ पे R है that's a wrong option. So ये invalid हो गया. So ये दो invalid हो गए. Okay, यहाँ पे भी एक में R है और इसमें एक में 1 है. So ये बचते हैं, right? We'll have to do these guys for some way. Okay. तो f for some x belong to 1 to e square. I mean like what? I don't know. F of x equals 0 for some x belonging to 1 to e square. Wait, 1 to e just, okay, fine. At 1 is just 1, and at e it is 1 upon e minus, which is like negative. So yes, sum x. Right, so second is correct. Third, f dash of x equals 0 for sum x belong to 0 to 1. 0 to 1. Well, that's like 0 to infinity, and at 1 it is just a positive. So no, third is wrong. Jab be third, that's wrong. Which means if second bachta hai. So 52 का b. What that means is like key. Second, okay, Q, that's correct. Whatever. So third once again नहीं, फिर first गया, फिर यहाँ पे R गया, just B. Second, third ऐसे also correct. So 53 का B. Awesome. Next question. Oh, okay. Sorry. Maths done. Let's go to physics. यार ये पहली बार है कि मेरा 1 घंटे के अंदर मैथ्स हो गया. This was probably easier question. जो भी है. Okay. First क्या है? 7 questions हो गया. Flat plate moving normal to its plane through a gas under the action of constant force F. Flat plate moving normal to its plane under through a gas under the constant force F. The gas is kept at low pressure. The speed of through a gas, huh? Normal to its plane. Okay, fine. The gas is kept at a very low pressure. The speed of the plate is V. V is much less than the average speed U of the gas molecule. So the following option is also. UV. Constant force F से move हो रहा है. Okay. And what about this thing, a flat plate? बस इतना ही दिया है. Normal to its plane. That's kind of a weird thing, right? Speed of the gas is this thing much less than the average speed U of the gas molecules. Okay, so the following is true. The pressure difference between the leading and trailing phases of the plate is proportional to UV. Phases. Huh? Okay. That pressure difference you're saying. Wait. And it's moving under the constant force F. And और कुछ दिया है. Speed of the plate is much less than. It's just like it's a constant force. It's just the drag force that is getting neglected. Okay. Viscosity अपने को लेनी है क्या? Resistive force experienced by the plate is proportional to V. I guess yeah. Viscosity अपने को देखनी पड़ेगी ना. Yes, we should. This is some weird fluid mechanics. I don't know इसमें कैसे करता हूँ. Okay, whatever. It's just as if like अपन Stokes law just apply करें. I don't know. Okay. Block of mass m circular cut with frictionless. Okay, so I think ये वाला right. Physics section पूरा hard रहने वाला है most likely. ठीक है. So yeah, दिख तो वैसा ही रहा है. It will be hard. So ठीक है ना, we'll just go to chemistry in that case. Yeah, समझ गया, hard है. Next, go to chemistry now. Okay, part 2 chemistry. Ideal gas expanded from P1. Okay, under different conditions, the correct statement about among the following is, or the work done on the gas is maximum when it is compressed irreversibly from this thing to this thing under constant pressure P1. What expanded from this thing to that thing under different conditions? What different conditions? Okay. The correct statement about. Okay, the work done on the gas is maximum when it's compressed irreversibly from P2 V2 to P1 V1 under constant pressure P1. Work done on the gas you are saying, and constant pressure P1, right? It's compressed, so इसका pressure increase and temperature क्या कुछ दिया क्या? कुछ भी नहीं दिया. Irreversibly, huh? Just that's the work done, like P1 and then okay. So A का okay, the adiabatic multiple choice है ना? Okay. So you're saying the maximum work done is just. No, I don't think so. Work done on the gas maximum when it compressed irreversibly from V2 to V1 against constant pressure T1. No, 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 no. Can't be the same. Wait. How do you even compress it? Because okay, so like assuming P2 chota hai, then your temperature should be less. Anyway, what if you could like, हाँ तो pressure को increase करो, then of course it's going to be easier to do, right? अच्छा, P1 is like bigger. Expanded from this thing and doesn't look very correct, does it? No, it doesn't. Maximum work done. What do you mean? In terms of what is this maximum? Efficiency type? I think so. Then it's just not maximum. It seems because irreversibility. Yeah. Wait. I don't know. If the expansion is carried out freely, it is simultaneously both isothermal as well as adiabatic. Yeah, okay, that's right. So B is correct. मैं सही कौन से correct है? 19 का B तो correct है. और क्या है? The work done by the gets less when it expands reversibly from V1 to V2 under adiabatic conditions as compared to that when it expands from V1 to V2 under isothermal conditions. Reversibly expands from V1 to V2 under adiabatic conditions. So work done on the gas is less. Wait, it's like just the heat transfer. So, it's like what is on the gas, right? Wait, no, you want by the gas. So it's expanded from this to that, right? Just, I get it. It is NCV delta T. Okay. Astronomical conditions is just nRT natural log of V2 upon V1. So, that's kind of weird. I mean, yeah. So, I mean like T1 natural log of V2 upon V1 versus, um, you know, NCV. और ये किस तरह की गैस है? Ideal gas. That's what you're saying. Okay, so I think it's like 3 upon 2, 3 upon 2 फिर R delta T. R तो कटने वाला है, just basically this thing. T2 minus T1, right? Which you can think of it like, okay, ऐसा 3 upon 2 T1. Okay, just V2 upon V, okay, it's like proportional to this guy. हाँ तो फिर ठीक है, just 1 minus V1 upon V2 in that case, because actually going from V1 to V2, so फिर it's like T1 कॉमन निकल T2 upon T1 just upon T2. Got it. Just this thing. So this versus that कौन सा बड़ा है? And what you're saying is कि Vulcan gases when it expands reversibly from okay gravitations less. Okay, so what we are claiming is natural log of V2 upon V1. That thing is less than 1 minus V1 upon V2. It's like asking ki, so V2 is bigger, I believe, right? Okay, so just V2, let's say V1 upon V2 equal to X is like negative natural log of X is less than 1 minus, or you can just do this natural log of X is less than, what am I kidding? Negative natural log of X is less than 1 minus X. That's what you're asking. When X is between 0 and 1 for any X, I don't know. So you're saying is X less than 1 plus natural log of X. इसका derivative क्या था? Just 1 upon X is like 1 minus 1, huh? Oh, the derivative is like positive in that particular range. So at X equal to 1, this is just 1 and 1 equal, right? तो उसके पहले, right? Yeah, this is actually bigger, which means कि इसके पहले this is actually less. 1 plus natural log of X is actually less, so it's opposite. So C correct नहीं है. The change in internal energy of the gas is zero when it is expanded reversibly from T1 equal to T2 and positive it expanded reversibly under adiabatic conditions with T1 not equal to T2. So this is wrong, it seems. Right? It's like adiabatic में less work नहीं ज़्यादा work करना पड़ेगा because why is that the case though? तुम्हारा डेल्टा U सेम रहने वाला है एक्सेप्ट तुम्हारी हीट ट्रांसफर जो है इसमें नहीं हो रहा है एंड देन इन दैट केस तुम हीट ट्रांसफर कर पा रहे हो ओके इसमें हो नहीं रहा इसमें हो रहा है right so the work you are doing by the gas right Q equal to W plus delta U दोनों के सेम है which means कि work done by the gas is Q minus delta U so इसका Q बड़ा है that is the thing and Q किसका बड़ा है of course in astronomical cases so oh it's like इसका क्यों छोटा होगा it's kind of weird है ये तो सही नहीं हो रहा है That's not making sense. Ah, so like what you're saying is 1 plus natural log of x minus x is bigger than 0 when x is between 0 and 1. इसका डेरिवेटिव just 1 upon x minus 1 होता है. So in that range it is positive. मतलब कि इसका maximum value होगी at x equal to 1, which happens to be just 0. So उसके पहले it should be negative, not positive, right? Work done is, this is not making sense now. Oh, this is isothermal में. So isothermal less than adiabatic बोल रहा हूँ ना मैं. Yeah, that's what I'm trying to prove actually. Oh, आपने कुछ बोला ना isothermal bigger than adiabatic. Right, bigger than adiabatic. Okay, okay, समझ रहा हूँ. So that's like asking is negative. Okay, it's bigger than that, which means yeah, okay, that is in fact correct. So this is actually bigger than that guy. Awesome. Right. So yes, it's actually correct. C is correct. So क्या है ऐसे ये 19 का C करेक्ट है. और क्या है 19 का C करेक्ट है. इसका अपन ने B करेक्ट कर ही दिया था. Okay, the change in internal energy of the gas is zero if it expanded reversibly from T1 to T2 and positive if it expanded reversibly under adiabatic conditions with T1 not equal to T2. Internal energy of the gas is zero if it expanded reversibly with T1 equal to T2 and positive under adiabatic conditions T1 not equal to T2. Change in internal energy. Like adiabatic conditions, right? Okay. So let me reverse it. Like work किया expanded. So it's actually negative, right? Negative change in resistance is negative if it expanded reversibly under adiabatic conditions because for a work done is negative. Yeah, of course. I mean, first law still काम करता है. Doesn't matter क्यों reversible वो ना हो. So this is not correct. D is wrong. Next question. For a solution formed by mixing liquids L and M, the vapor pressure of L is plotted against the mole fraction M in the solution. Okay. And these are okay mole fractions of L and M respectively in the solution. Then the correct statement applicable to the system is mixing liquids L and M, the vapor pressure of L plotted against the mole fraction M in the solution as shown. So, kya? Wait, what? Pressure of L. So PL, that's the vapor pressure of L plotted against the mole fraction of MXM. Solution is shown in the figure. Here XL, XM represent mole fractions of L and M respectively. ठीक है ना. तुमने जो दो लिक्विड्स तुम्हें मिक्स किए L and M, उनका नाम है. Okay, got it. The correct statement applicable to system are the point Z represents vapor pressure of pure liquid M जब XM 0 होगा. Are you serious? Yeah, okay. XM equal to 0, that is at that point. Okay, no, not pure liquid M. No, because ये 0 हो गया ना. XM तो 0 हो गया, which means कि तुमने यहाँ पे 0. I think ये 0 और 1 चाहिए. नहीं, L यहाँ पे मिनिमम है ना. So XM is actually higher. Yes, that makes sense. So यहाँ पे pure liquid L है. Rod's law is obeyed when XL approaches 1. हाँ. Guess I don't know क्या बोल रहे हो. XL approaches 1. Then Rod's law is obeyed. Okay, XM approaches 0. At that point, Rod's law is obeyed. You mean like for PL? Ah, okay, got it. So like pressure of L is proportional to P naught. Yeah, okay, that does look correct. Yeah, okay, right. So B is correct. Training answer B. और क्या दिया है? Attractive intermolecular interaction between L is in pure liquid L and MM in pure liquid M are stronger than between LM when mixed in solution. Molecular interactions between so ये actually like positive deviation है ना? Yeah, just positive deviation. Okay. So what does that actually mean? कि somewhere in the middle जब भी तुम this is not making sense. So L का pressure extra है than what should have been, right? Yeah, that is basically what it's saying. So the attractive intermolecular interactions between L and pure liquid and MM in pure liquid are stronger than between LM when mixed in solution. हाँ राइट, बिकॉज वो ऊपर चला गया जिस मीन्स कि यहाँ पे राइट वो फ्री स्पेस बचेगी, दैट मीन्स कि यस यू कैन डू दैट इन दैट केस। कौन सा वोलेटाइल है कौन सा नहीं है, कुछ भी नहीं दिया राइट, ओके जो भी है। Additive intermolecular interaction between L and pure liquid and M in pure liquid are stronger than between LM when mixed in solution. I think that's right. Because LL pure liquid form, I think it's going up because of that, right? Yeah, it doesn't want to stay in the liquid, it seems. But then doing so will just, concentration less karega. Well, that doesn't actually make any sense because, okay, I don't know, just move on. Just move on. Correct statement about the oxygen HClO4 and HClO, I don't know. Okay. Okay, so we don't care about all that stuff. Yeah, organic chemistry. Honestly, I know अपना गलत होता है हमेशा, so why worry about it? Crystallized solid of pure substance has face-centered cubic structure and cell edge of 400 picometer. A equal to 4 times 10 power, because it's 10 power 12, right? Just 10 power negative 10 that case. If the density of the, that's pico, right? 10 power 12. Yes. If the density of substance in the crystal is this thing, so rho to mein diya 8 whatever. Then the number of atoms present in 256 grams of the crystal is, so divided by the density, just get what, like 24 to 3 and then 16 to 32 centimeter cube of volume of the crystal basically, right? Which is like 32 times 10 power negative 6 volume. Okay, so edge length है, that's just basically what is this thing, right? So कितने इसमें unit cells हो गए? So a cube is what? A cube is just 64 times 10 power negative 30 divided by this guy, just get it basically number of atoms, जो भी है, number of edge cells, sorry edge is कितने हैं, all small and whatever already use कर चुके इसको, divides 1 upon 2 times 10 power 24. Okay, so it's like half. Okay, over there, yeah. Crystalline pure substance face centered cubic of cell edge for pure substance face centered cubic, right? So like हर edge में तुम्हारा, sorry हर cell में कितने 4 atoms रह गए? Pure substance, awesome, बढ़िया. Okay, yeah, okay, that's awesome. It's like 4 times this guy, of course. So just 2 times of 10 power 24. So n is just 2. 26 answer 2. 27. The conductance of this blah, 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 aqueous solution of a weak monobasic acid was determined by using conductivity cell consisting of flattenized electrons. Conductance between electrons is this thing. L equal to what? 12 centimeters. Seriously. You can L equal to 1.2. Okay, then area of cross section 1 centimeter square. So A is equal to 10 power negative 4. The conductance of the solution was, say this thing. So conductance, which is G, that's equal to what? 5 times 10 power. I'm assuming ये SI unit है. pH of the solution is this thing. So concentration of H plus is equal to 10 power negative 4. The value of limiting molar conductivity of this weak monoxic acid in aqueous solution, limiting molar conductivity, is this thing. The value of Z is pH of the solution is given. Wait, if there is like a pH, that means कि अपन अल्फा निकाल सकते हैं, right? K अपने को दिया है क्या? Okay, then she didn't give us anything. Huh. Transfer molar aqueous solution. Okay, you actually know what alpha is anyway, right? Yeah. Because ये बड़ा 10.86 से तुम्हारी concentration क्या है? 15 times 10 power negative 4. Which is 10.84. मतलब कि क्या? Alpha is 1 upon 15. उतना decompose, it's a monomeric acid, right? Okay. तो उतना तुम्हारा निकल गया, and that's, yeah, okay. So alpha times the molar conductivity is our limiting molar conductivity. Is actually our actual molar conductivity. Yeah, just 1 upon 15. You get the thing. Right, it's like what? 15 times, oh yeah, 10.84 is our molarity, actual molarity. That times of its limiting molar conductivity, which is, oh, we actually want to figure that out. जो भी है इसको मैं lambda बोल रहा हूँ. And this is equal to what? So lambda times 10 power negative 4. This is equal to our actual conductivity, which is what? It's like what was the thing? Uh, it कैसा रहता है? Resistance equal to rho L upon A. So it's like conductance is equal to conductivity or ठीक है जो भी conductivity times A upon L, right? Okay, so basically conductivity is what? Lg upon A. So that's what we are looking for. 1.2 times G is this thing would have 10.87 upon A is 10.84, 10.83 आएगा, okay, which is like 24 times 10 power negative 4. So lambda is just 24 it seems, right? Centimeter, this is SI units, right? So 24 S meter inverse and mole inverse. Okay, so then it's like 100 actually. Okay, so as that is just 24. Awesome. 27 का 24 but क्या है 0 to 9? Oh wait, but that's not 0 to 9 unfortunately. Wait, did I mess up somewhere? Must have messed up somewhere. Shit, 5 times. Okay, मैंने इसमें 2 times 10.87 लिख दिया गलती से. Okay, so it's like 5 over there. मतलब यहाँ पे क्या चाहिए? Just 6 times 10 power. Okay, okay, just calm down. Let's do it correctly. So what do you have? L, which is just 1.8. So 5 is 6. 6 times of 10 power negative 7 upon area, which is 10 power. Oh no, that's it. 10 power negative 4 as well for some reason. जो भी है. So it's just 10 power negative 3. Like distance of 10 power negative 3, that's equal to lambda times 10 power negative 4, I believe. Right? So your lambda is what? It's just 60. One mole के लिए ऐसा रहेगा. It's like the one of distant power negative 4 moles है. No, that's not. Wait, molarity, right? So for 1 molar it says that. 10 power negative 4 molarity. Yeah. Okay. That explains it. Just this thing मतलब कि 60 आएगा यहाँ पे. Okay, I guess मैंने कहीं यूनिट्स वगैरह में झोल झाल किया है. Whatever जो 6 है वो फेस वाली दिख रही है. So I'm gonna go with that. Let's say answer 6. Assume it's correct. Is alpha going to be there? That's just possible. That's sort of 15 it seems, right? Because that's just 15 times 10.84. So just this 10.84. That's the thing. That's the thing. Sure. Molar. Yeah. 6. Next question. Just move on. 28. 28 is sum of the number of we don't care. Yeah, no friends. Question 3. Okay. That I don't care about. मुझे नहीं करते आता है. Okay. और ये तो वैसे मुझे नहीं आता है. So हाँ ठीक है. So that's done. Chemistry is done. इसमें 2 ही questions थे. Both were hard. I mean hard नहीं but like जो भी है. ये तो नहीं है. Oh wait, this is actually probably doable. मैंने देखा भी नहीं. Wait, is it? That's just physics, isn't it? Yeah, okay. ठीक है ना, चलो physics start करते हैं that is. ऊपर जाओ. Okay, ये तो जाता नहीं है. Mass time circular cut with a frictionless surface as shown. The block rests on the horizontal frictionless surface on a fixed table. Okay, fixed table, frictionless surface, horizontal. ठीक है ना. Initially, right edge of the block is x equal to 0 पर है. Okay, in coordinate system fixed to the table, point mass m is released from the rest at topmost point of the path shown. When the mass loses, और ये जो चीज है, it's frictionless or what? Cut with frictionless surfaces. Okay, got it. Right. When the mass loses contact with the block, its position is x and the velocity is v. At that instance, the following options is correct. So just अभी तुमने initially rest पर है, at rest. Okay, और ये भी अभी rest पर होगा. Okay, cool. Slides down. When the mass loses contact with the block, its position is x. अच्छा ये, सो ये जो है, अच्छा ये वाला कॉर्नर एक्सिक्यूट नहीं, ये एक्सिक्यूट जीरो, ओके जो भी, and velocity is v at this instance of the following options is or are correct, ठीक है ना, ठीक है। आह, इस पोजीशन अपने को निकालनी है, राइट? x velocity is y, velocity अपन शायद से निकाल सकते हैं because you know this energy conservation, right? I mean velocity is actually easy to figure out, but then position is not. Like normal velocity is not going on. अरे यार ये तो काफी अजीब हो जाएगा। देखो कि your y coordinate velocity can probably be just that, and these should match up. Well, think. I mean, we can figure out what v is. Center of mass is just this thing. हाँ ना, we'll just have to actually figure out the thing. So, अच्छा इसमें थीटा क्या है? कुछ इसमें दिया है क्या? नहीं, right? Because the block is this thing. Awesome. Block capital M, right? So need M अपन इसको look कीजिए वहाँ. देखते हैं ना, so just first of all C और D तो अपन कर सकते हैं, I guess. But then how do you do A? Position of point mass. Uh, yeah, okay, center of mass change होता है ना? Okay, that should still have the same position. I mean, in the x coordinate, right? Okay, got it. So position अपन try कर सकते हैं actually, इतना बुरा भी नहीं है, right? Um, suppose की position x है, you just have mx plus, wait a second, x coordinate of velocities, that's some complicated things going on. Given this guy's position, तो जानते हो कि उसकी position क्या है, but do you actually even know what this guy's actual position is? No, you don't. No, you don't. Oh, we do know कि, right? Okay, that is something which we know. So ये जो point है, we just track this guy's position. Initially x equal to 0 पर है, और ये x equal to negative r पर है, right? So what you want is like m times इसकी जो displacement हुई होगी, which is इसकी भी x value है, x and then just minus r, right? मतलब इसका जो भी x coordinate आ चुका होगा, initially minus r पे था, like अब plus r हो चुका है, okay, got it. तो yeah, subtraction and then plus capital M times, अब इसकी भी ये जो चीज है अभी x पर है, first initial x 0, so just instance of x equal to 0, right? Yeah, that looks it. So just x is equal to what? Negative mr upon m plus m. ऐसे स्क्वायर रूट ऑफ 2 क्यों डाल रहे हैं लोग? How does that actually make sense? Square root of 2, are you serious? No, that's square root of 2 cube. That doesn't make sense, right? R square root of 2 or something. नहीं, बट अपन सिर्फ x coordinate का देख रहे हैं ना, so yeah, we just took x coordinate, तो फिर ये कैसे हो गया? No, it should just be like negative mr upon m plus m. That's it. Not negative square root 2 mr. Okay, ठीक है. That's the point. Mass m is this thing. Okay, velocity निकालनी है. We can kind of do this thing. Right. So दोनों का momentum same रहेगा. So like our p squared. p कितना आएगा? Just equal to small m v, right? A point mass m, of course. So energy should be half mv squared plus इसके लिए just p square upon 2 capital m हो जाएगा, right? So just m squared v squared upon 2 capital M. This is equal to our final जब initial energy थी, which was potential energy. तो you know mgr, yeah, that's true. फिर 2 उधर गया, m कटा, just v square times 1 plus m upon m is equal to 2gr. Awesome. So you know v is just equal to what? This is kind of not going good. Okay, square root of 2gr upon, oh yeah, okay, b actually works out. Second concept b correct है. और क्या है, the x component of the displacement of center of mass is negative mr upon, right? Wait, actually yeah, x component of the displacement of the center of mass of the block is this, that negative mr upon m. इसका जो x coordinate was just this thing, and then right, so that minus 0, of course. So c is correct, right? Because till that point वो इसके साथ, okay, so b का, okay, ac भी correct है. और क्या है, the velocity of block is v equal to negative, okay, capital M का negative m upon m times this guy. This one just, oh no, it's not, definitely not. You just have to do right that thing. So yes, ठीक है, next question. Log m hangs vertically at the bottom end of the uniform rope of constant mass per unit length. The top end of the rope is attached to a fixed rigid support at O. Transverse wave pulse 1 of wavelength lambda naught is produced at point O of the rope. Pulse takes some time to reach A. Okay, A reach करने का time लग रहा है. Constant mass per unit length. क्या? Hangs vertically at the bottom end of a uniform rope of constant mass per unit length. ठीक है ना, जो भी है. Top end of the rope is attached to a fixed rigid support O. Transverse wave pulse of wavelength lambda naught is produced at point O on the rope. The pulse takes time TOA to reach O. ठीक है. If the wave pulse of wavelength lambda naught is produced at point A, pulse 2, okay, without disturbing the position of M, it takes time EAO to reach O. Which of the following is correct? Or right, so uniform mass per unit length, call this lambda. You cannot use mu, right? So, yeah, it's just mu required. Okay, whatever. The time TOA equal to, no, that's not right, because it's your speed है, c is just given by what? Wait, इसका जो wavelength है, it's right, initially तुमने lambda not पाया है, right? Yeah, तुम्हारी initially wavelength तुम्हें दी हुई है. You know the speed though. Okay, do you know the frequency? Because without that, how? Okay, actually you do know the frequency. Oh, the frequency remains constant throughout. Important thing, of course. Okay, throughout like reflection भी वापस होने वाला है. I don't care. Frequency है. So yeah, the frequency is the same throughout. So you just want to write in that form. जो भी है. C क्या है? C is just square root of T upon mu, right? So you know T upon mu times. Okay. It's kind of weird. So what do you want? So it changes, right? Mm-hmm. So you know C2 upon C1 is just equal to, right, that thing. So you know C as a function of x is like what? C and then square root of mu naught upon mu, right? I guess so. And then initially just C tha, that was just, you know, what was it? Just lambda naught times f naught. So C is equal to, yeah, that must be the thing, of course. Hey, even though the frequency, right, we don't care about it at all. Of course we don't. Valency जोड़ी, okay, we don't care. C equal to C naught, yeah. So C naught यहाँ पे starting पे, यहाँ पे, okay, got it. What do you want? Just want the time required, like integration of dt upon v, which is just like square root of mu upon C naught square root of mu naught, and then just want dx, right? This thing. So मैं ऊपर जाऊँ कि नीचे जाऊँ? Yeah, just got this thing 1 upon C naught square root of mu naught. Well, that's just t, right? Square root of t for both of these guys. It's just that 1 upon square root of t, and then you got square root of yeah, okay, yeah, okay, dx, and that's it. That's pretty much just it. Of course. Oh, it takes the same time, so A is correct. So third का A correct है. और क्या है? The velocity of the block pulse 1 pulse 2 are the same at the midpoint of the rope. Yes. The wavelength of pulse 1 becomes longer when it reaches point A. So तुम O से start कर रहे हो, इसके लिए कोई भी wavelength है. Add to your, wait, but your tension also changes. But then, ooh, something went wrong again. Shit. तुम्हारा mu थोड़ा सा change हो रहा है, तुम्हारा tension change हो रहा है, right? So okay. Should be like T1 upon T2 or something like that. Your mu is kind of constant. Okay. So this is not going to help. What do you want to do? Just C is C naught square root of mu naught. Okay, that's not going to help. C is equal to C naught square root of T upon T naught, right? Okay, awesome. So क्या है? Just integration of dx upon C, which is नीचे आएगा C naught square root of T, ऊपर आएगा square root of T naught, and then you got dx. So T is a function of x, right? But तुम्हारा okay, it's like symmetry, so doesn't matter कि तुम कैसे जाते हो. It's basically like the square root of T naught upon वाली C जो चीज़ है, that's just, yeah, that's just square root of mu. So square root of mu integration of dx upon square root of t, right? That's our time required. So yes, it's still the same. Okay, cool. So as it moves down, हमारी जो tension है, it's actually it's getting complicated. तुम्हारा C change हो रहा है, तुम्हारा wavelength change हो रहा है, तुम्हारी frequency change नहीं हो रही, right? Okay, ठीक है ना? So at this point हमारा C क्या हो गया? हमारा C बढ़ नहीं छोटा हो गया ना? because हमारा tension जो है just tension has reduced. यहाँ पे tension maximum था, so your tension is reduced. मतलब कि हमारा C छोटा हो चुका है, हमारी wavelength भी छोटी हो गई. Okay, the length of pulse one becomes longer when it reaches A. No, it becomes shorter because for the frequency same as so wavelength is equal to C upon F. C becomes shorter, it also becomes shorter. The velocity of any pulse along a rope is independent of its frequency and wavelength. Yes, actually. So D is correct because at some certain point, Mari, yeah, that's right. So D is correct. Or क्या है? Length of pulse one becomes longer, which is point A. Got it. So C is wrong. D is correct. Next question, fourth. Human body surface area approximately this thing. Okay, surface area is just 1. Normal temperature is 10 Kelvin about surrounding temperature. Take the room temperature to be T naught equal to 300 Kelvin. Okay, room temperature is 300. The value of sigma T power sigma is the same as possible. The following is correct. Okay, तो उतना अपन absorb कर रहे हैं. Fine. Amount of energy radiated by the body in 1 second is close to 60 joules. अपनी एमिसिविटी गॉड वी डोंट नो अपनी एमिसिविटी क्या है. सो कैसे करूंगा मैं इसको? Should we just take it as like a black body? The amount of energy radiated by the body in 1 second is close to 60 joules. This is the thing. So इसके पास slightly above है, so it can't be that much of a big deal, right? Just yeah. So distance of 1 meter squared, so just 460 watts or something. 1 second. Yeah, it's like 460 joules के पास में, not 60 joules. Wait. Oh, okay. You don't want that. Oh, okay. You want actually this thing. Got it. समझ रहा हूँ मैं. So what you have like A sigma T power 4, T naught power 4. Then you just have, right. So delta T up is like 1 plus. ठीक है 4 delta T upon T naught, I guess, which is ये चलिए तो पॉइंट पता है. So like A ये जो अपने पावर दी थी 4A T delta T upon T naught. Awesome. Delta T is like 10, so just 1 upon 30 आ जाएगा इसमें. 4 times 1 times P is just this thing 460 times ये चीज just 1 upon 30, right? Just do this thing. So this is approximately like 16, and then you got with the 40 से थोड़ा सा बड़ा है. Okay. 16 and then you got 24, which is 184 upon 3. Yes, close to 60 in fact. So A is correct. Or क्या if the surrounding temperature is reduced by a small fraction delta T much less than T naught, then to maintain the same body temperature, the same living human being needs to radiate this much more energy per unit time. So the energy radiated अपन निकाल चुके हैं, just this thing 4A, okay, 4A sigma T naught cube, and then wait, I'm trying to get a hang of it. अगर यहाँ पे T naught power 4 निकाल मैं just T power 4 को, then it also it actually works, right? Because both are also same as T power 3. Okay, and then it's just delta T. तो हमारा जो delta T है, it is now what? Yes. Okay, so this is in fact correct because T naught is approximately T. That much works out. Yes. So B is correct. और क्या है? Reducing the exposed surface area of the body, curling up allows humans to maintain the same body temperature while reducing the energy lost by radiation. Yes, in fact. Wow. That explains what you feel when we curl up. If the body temperature rises significantly when the peak in the spectrum of electromagnetic radiation emitted by the body would shift to longer wavelength. So temperature बढ़ाओगे, then your wavelength becomes longer. No, it becomes shorter. So that's wrong. Okay, next question. Circular insulated copper wire loop twisted to form loops of area A and 2A as shown. At the point of crossing, the wires remain electrically insulated from each other. The entire loop is in the plane of paper. A uniform magnetic field E point is the plane of paper. At equal to 0, the loop starts rotating about the common diameter as axis with a constant angular velocity omega in the magnetic field. So the following option is are correct. So it's moving like this. यहाँ पे area है A है, ये area 2 है जो भी है. So what do you want with this thing though? A loop in the point, okay. Form magnetic field E points into the plane of paper. Okay, the EMF induced in the loop is proportional to the sum of the areas of the two loop. Actually, no, it's like difference because इसमें right मतलब flux है, it's like changing. तुम्हारा फ्लक्स कैसे चेंज होता है? सपोज तुम्हारा इसमें पॉजिटिव चेंज हो रहा है, ऐसा कर लो पूरा, एंड देन यहाँ पे जो है as you go up like that. Okay, so actually right you have to have this kind of thing. So area A, right? Suppose यहाँ पे E potential है from this loop, then यहाँ पे E potential रहेगा like जब तुम clockwise जाओगे, right? Okay, so like ऐसा E potential रहेगा, you know. So actually अगर अपन ऐसा जाते हैं like यहाँ पे E and then यहाँ पे फिर negative E, okay, इसमें 2E रहेगा ना. So like difference of course. EMF induced in the loop is proportional to the sum of the areas of the loops. Now the amplitude of the maximum net EMF induced into both loops is equal to the amplitude of the maximum EMF induced in the smaller loop. Amplitude of the maximum net EMF induced due to both the loops. What? Sorry. Amplitude of the maximum net EMF induced due to both the loops is equal to the amplitude of maximum EMF due to the smaller loop alone. Yes, I believe in that. Because yeah, the net EMF induced between both loops proportional to cosine of omega t. To start करें at t equal to 0 is just okay. So at t equal to 0 क्या हो रहा है? In the plane of paper, it was so area vector is it pointing towards? I mean, yeah, it's going inside. So this is going inside, right? Yeah. Omega is in this. क्या फर्क पड़ता है? Right. So this direction. ठीक है ना? So just that's like okay. Speed dot A. So we'll just mark this as theta. This is just like changing. So cosine theta का derivative is sin theta sin omega t, right? This is just omega t over there. Of course. So sin omega t चाहिए इसमें, not cosine omega t. The rate of change of flux is maximum when the plate of loop is perpendicular to the plane of the paper. Plane of loops is perpendicular to the plane of paper. Yes, in fact, because then when your theta is like 90 degrees, so that's sine. Yeah, that works out. So D is correct. D is correct and D is correct. Next question. Sixth. In the circuit shown, L equal to this thing, C equal to this thing, blah blah. Connected in series with AC source V equal to V naught sin omega t. So the following options are correct. The current will be in phase when the voltage is equal to this 10 power 4 radians per second. ओमेगा तुम्हें दिया है, तुम्हें वोल्टेज दिया हुआ है, इंडक्टर्स तुम्हें दिया है, ठीक है. करंट विल बी इन फेज with the voltage if omega do this thing. Okay, so अपने को C, right, C omega equal to L omega चाहिए. Is that correct? C is what, 10 power negative 6. Oh, दोनों माइक्रो में है तो 1 upon C omega, right? Okay, 1 upon C omega should be equal to 1 upon, so equal to L omega. Okay, LC omega square is equal to, okay, like omega should just be equal to what? 1 upon square of LC, which is what? ऊपर, okay, it's about 6 upon 1. So 10 power 6 radians per second चाहिए, not 10 power 4. Yeah. Okay, cool. The frequency at which the current will be in phase with the voltage is independent of R. Yes, it is. Okay, at omega approximately 0, the current flowing through the circuit becomes nearly 0. What? So the current flowing through the circuit, becomes nearly 0. I don't understand. तुम क्या बोल रहे हो? Omega approximately 0, the current flowing through the circuit nearly becomes 0. कैसे? I don't wait. But the impedance is like, impedance is just 1 upon L omega तो मर गया, R है, and then C omega is like it's approaching infinity or something. So your impedance is actually approaching infinity, right? Then B upon, okay, that's approaching 0. Yes, it is in fact somehow approaching 0, assuming steady state. That's of course wrong because steady state for number. But ठीक है ना, JE है, चलता है. So C is correct. Omega much bigger than 10 power 6, the circuit behaves like a capacitor. much bigger. No, it becomes like an inductor because 1 upon c omega, right? वो factor कम हो जाएगा when omega becomes bigger, right? Okay. Yeah, it's gonna become less, and then that's why. No, it becomes like inductor actually. So C is correct. D is correct. That's it. C is answer B and C. Next question, seventh. Okay, from an axis prism of angle A, refractiveness mu is found at the angle of minimum deviation delta m is equal to A. Which the following options are correct? Angle of minimum deviation. अपने किया है ना derivation पूरा आपने बताया that happens when I and R are the same, right? I and E, whatever. You know, so it's like parallel रहेगा in the prism. Okay, found that the minimum angle of deviation, minimum deviation at m equal to A. The following is all correct. For the angle of incidence I1 equal to A, the ray inside prism is parallel. अच्छा पहले कोई करना पड़ेगा, right? So this is our angle of prism. This is like mu over जो भी है. ठीक है ना? So ये लेंस करने वाली है. This is going to be complicated. यहाँ पे तुम्हारा angle of incidence है. This thing is your angle of refraction. यहाँ पे तुम्हारा एक और एंगल ऑफ रिफ्लेक्शन सेम आ रहा है, which is angle of incidence, right? Yeah, exactly. So ये जो एंगल है, this angle is angle of incidence minus angle of reflection, that is this guy, right? That's your del. So yeah, like del is just equal to इन दोनों का sum, which is like in this case just 2 times of I minus r, and then a कितना है? So you know कि a plus ये चीज is like y minus r plus y minus, okay, yeah, y minus 2r. So a is equal to 2r, of course, right? That looks correct. कुछ मैंने मिस किया क्या इसमें? No, probably not. So okay, अपने करना क्या है? For angle of incidence I1 equal to A, the ray inside the prism is so minimum deviation is equal to actually A, right? Okay, got it. So ये equal है, oh, I minus R equal to R. Okay, I is equal to 2R. I is equal to 2R for this to be happening. Or you could just say A upon 2 is what? Okay, okay, okay. So R equal to A upon 2 and I is equal to A. We have to figure out what A is. अपने को mu दिया हुआ है. Okay, ठीक है. So your mu is what? Like sine I, sine of A upon sine R, sine of A upon 2. That's just equal to mu. So mu is 2 cosine of A upon 2. Okay. So for this, okay, angle of incidence I1 equal to A, the ray inside the prism is parallel to the base of the prism. Yes, yes, वही तो हो रहा है. So A is correct. Or for this prism, the refractive index mu and the angle of prism are related as A equal to half cosine inverse of mu upon 2. Not half, it's 2, right? It's gotta be 2. I'm making some kind of mistake. God. What's A? So I is equal to A and R is equal to yeah, A upon 2. So फिर just 2 cosine inverse of 1 upon 3 upon, not this thing. So A is correct, 7th answer A. और क्या है? B is not correct. At minimum deviation, the incident angle I1 and refracting angle R1 are the first. At the first, refracting surface are related by R1 equal to I1 upon 2. Yes, yes, that's right. R is equal to 2. Okay, so C is also correct. और क्या है? For this prism, the emergent ray at the second surface will be tangential to the surface. Oh, okay, so emergent ray at the second surface will be tangential to the surface. So critical angle चाहिए. When the angle of the incidence at the first surface, ठीक है, we just do this thing. So, you know, तो ये critical angle है, which is what? We're going to take a sine. Yeah, okay, 1 upon mu, which is 1 upon 2 cosine of A upon 2. This is a very, very weird actually. I 90 चीजें चाहिए, but this is just that. Mu is just this guy though. Sine of this guy. It's just be, yeah, sine inverse of 1 upon mu, I believe, which is this thing. So this guy is sine inverse of 1 upon, yeah, okay, that's something. मैं थीटा बोल रहा हूँ. Oh shit, लंबा होने वाला है. We'll have to do it. So कैसा हो रहा है ये? This is so stupid. So that's our angle theta, so that actually happens. Right. This is your angle theta. Okay. And then at that point, what's our, yeah, ये theta है. like that's just A over there, and you got this. What is this angle going to be, right? Yeah. So you just ये क्या होगा 90 minus theta. 90 minus theta plus A is what this angle is, which is just okay. So 90 minus theta plus A, and then you want 90 minus this guy. That's what angle of incidence. Incidence का angle just theta minus A it seems. Yeah, that's the thing. Because, right, so angle of incidence is theta minus A, which, right, okay, it's getting complicated actually. No, that's not the angle of incidence, that's just the, oh, that's the angle of refraction, sorry. Okay, the angle of refraction should be this thing, मतलब क्या, sine I is equal to mu sine R. ऐसे mu तो होगा ही. Okay, so let's just do this thing. Sine I is equal to mu is 2 cosine of A upon 2, and then you want sine of R, sine of this guy. Okay, so sine of theta, so sine theta cosine A minus sine A cosine theta. We'll see क्या होता है. और इसमें अगर A upon 2 है तो it made sense, but then that's not gonna make sense. ठीक है, it's like you got cosine of A upon 2, right? We'll need to figure out इस sine में वगैरह क्या होने वाला है. Hopefully कुछ अच्छा हो जाए. So what's sine of theta, by the way? Just 1 upon 2 cosine of, yeah, okay. So you can just 2 cosine A upon 2, then you have 1, so cosine A upon 2 cosine of A upon 2 minus sine A upon cosine theta, which is how much? Sine is just this guy. So what is this? Square root of 1 minus E cheese, right? Okay, cool. And that comes out inside. Okay, I'm trying to understand this thing. So ये क्या हो जाएगा? Just cosine A minus sine A upon, or not upon, actually times. Okay, times square root of 2 cosine A upon 2 square. It's like 4 cosine square A upon 2, and that minus 1 it seems. Yes. So sine of this guy. I think ये negative में चाहिए, right? But I missed something. That's a negative, right? Sine theta. Sine theta is the one that's doable though. Yeah. It's the critical angle, of course. Right. Okay. No, it's actually the negative of this thing. So sine A is part of this. Okay. Does that make sense? That makes sense. I mean, like, okay, 1 upon 2 cosine of A upon 2, that's actually a smaller number. Okay, so cosine of 2 cosine of A upon 2 is actually a number bigger than 1. Okay. So, ये चीज़, okay, it's not guaranteed it's bigger than 1 or not. What we got is very different though. Yeah, minus A over, because like, that's just A plus theta. That's what this is. Time minus this guy is minus A. It should be theta minus A. तो उसका अपने को साइन लगने वाला है ना. And that's our angle of refraction, of course. Come on. What's going wrong? Don't get it. No, then I guess it's just wrong, basically. Because, yeah. Just have sine theta cosine A. Sine theta is this guy. So this cosine of A पहले चाहिए, right? Yeah. और ये बाद में चाहिए रहेगा. So it's wrong. It's actually opposite of this guy. Next question. A drop of liquid of radius r equal to, okay, अपन ने सही से correct सारे किए ना. कौन सा question चाहिए? 7th question. Yes. 8th question. Come on. 5 questions. Okay. Single digit integer ranging from 0 to 9. Both things to order. Okay. Drop of liquid of radius this thing having surface tension divides itself into k identical drops. In this process, the total charge change in the surface energy U equal to this thing, k equal to this thing. Then value of alpha is radius दिया है, surface tension is equal to, okay, divide itself into k identical drops. Total change in the surface energy is given, okay, k equal to k identical drops. Okay, wait. जिससे उनका drops का radius r है, like r cube times k, that is equal to r squared. Okay, and change in energy, I think now delta u upon s, like 4 pi s, that's equal to change in r squared का sum. So just capital R Oh, it's q over there. R squared minus k r squared, right? Yeah. Value of alpha is, I guess you can do this. So what do you get? R is just 1 upon k ki power 1 upon 3. Okay, just do this thing, right? Keep, kr square is just r cube upon small r, right? So you can just r squared times 1 minus r upon r. And you just want to figure out what is, right? So k is just r upon r ka cube. Interesting. Why is it like bigger some reason? Oh, okay. The change in energy is like it's now bigger energy it seems. Okay, so you have a negative, you have a positive icon. That is very weird. Yes. Wait, something's going wrong, isn't it? Kr squared. Oh yeah, that was just r cube upon r, of course. So that is correct. R squared common निकालो, just negative 1 plus r upon r. Yeah, okay, cool. So ये क्या हो जाएगा? Just so for this x value is x minus 1 times r squared. Okay, so delta u is just 10 power negative 3 upon 4 pi s. What is s? S is this thing. So 0.1 upon 4 pi. Awesome. Negative 1 upon 4 pi time. Okay, और यहाँ पे just r squared भी चाहिए, which is 10 power negative 4. So क्या मैं distribute it? ये गया just 10 power negative 5. So 10 power 2. 10 power 2 is equal to, oh god, just a little too big. Is that right? It's going to be r squared over there. Ah, interesting. This should not be working though. 1 4 pi s r squared. Just 10 power 3 cubes. I mean, this should be something like 10 power negative something. तो ये तो काम नहीं करना चाहिए था, but s okay r squared, that's 10 power negative 4. Something's not right. K equal to 10 power alpha if K is. Wait, do you mean like, oh, okay, that's kind of weird. Definitely not expecting this, but जो भी है. So 100. Are you serious? Wait, doesn't make sense. That can't be the case. Cube of that though. Okay. Just 101 ka cube, huh? That's what K will be. So like 10 power 3 approximately. So I guess alpha is 3. 8's the answer 3. Okay. That is kind of weird. Change in surface energy to this guy, right? That's what I did. Okay, 8th answer 3. Next question, 9th. Electron in hydrogen atom undergoes a transition from orbit with quantum number n I to another with quantum number n f. Vi, B, f are respectively the initial and final initial energies of this electron. Vi upon V equal to this thing. Smallest possible value of nf is. Potential energies. Okay. Vi upon Vf is like 1 upon n I squared. Okay, nf squared upon ni squared. ठीक है ना? Transition. Okay. So we don't know बड़ा है कि छोटा है. ठीक है. Smallest possible value of nf. Okay, like 6.25. Huh? ठीक है ना? So like nf is equal to 2.5 times ni, and this should be some kind of integers like 5 का multiple है. That's the basic thing, right? Smallest possible value ni 2 है and nf 5 है, so that works. 9th का answer 5. Yeah, that should be right. Next question, 10th. 10th is monochromatic light is traveling in medium of refractive index and is equal to this thing. It has a stack of glass layers from the bottom side at an angle 30 degree. Okay, the interfaces of the glass layers are parallel each other. Okay, it goes like this. The refractive index of the different glasses are notably increasing as nm equal to. Achha. The nm is the refractive index of the m and delta n equal to 0.1. See figure. The ray is refracted parallel to the interface between the m minus 1 and m glass जो भी है, and it does that and then it's like parallel to be. What is the value of m? Oh, that's all you want. मैं ये फर्क नहीं पड़ता कि कितना डिस्टेंस कवर किया वगैरह. Okay, okay, that's all you want. ठीक है. So what is the value of right m? Uh-huh. That's doing it. So it's at angle of incidence 30 degree. Okay. So what you just have sine 30 degree, which is like 1 upon 2 times initially जो refraction is n, that is equal to यहाँ पे जो refractive index रहा होगा, right? It's 90 degree. That's what I'm assuming, right? इसमें m के इसमें, right? So sine r is just 90 degree, just one over there. और यहाँ का so mth, right? इसका refractive index. That looks about the thing. So just n minus m delta n, of course. Okay, that should do it. So our m is n upon 2 delta n, which is n is 1.6 upon n delta n is what, 0.1, so 2 times of 0.1. So 16 upon 2 is like 8, m equal to 8. 10th answer 8. Next question. 11th. Stationary source emits sound of frequency this thing. The sound is reflected by a large car approaching the source with the speed of this thing. The reflected signal is received by the source and superposed with the original. Stationary source emits sound of frequency. Okay, got it. Here's F naught, or sound is reflected by a large car approaching the source. Car approaching the source with the speed of this thing. So, wait, this source emits stationary source. So V source equal to 0. Frequency is initially just 492 hertz. Large approaching the source with the speed of this thing. Reflected signal is received by the source and superposed with the original. Whatever the feed frequency. It's easy. Okay. So C minus V observer upon C minus V source रहता है ना? Yeah. Observer का इस केस में क्या? Okay, so you have to multiply that 2 times, right? First reflection. So yeah, first is doing that, right? Okay, so ये source is just stationary, and then V observer is, I don't know, just V, right? So it's moving with V, I guess. So just V equal to 2 meter per second, and then C is equal to 330. Okay, got it. C minus V upon C, just C. That is that frequency now. Okay, that terms of और अब ये ऐसे जा रहा है, right? Yes, that's the thing. Oh, it's positive. Yeah, observer उसके towards move कर रहा है. Okay. And then अब क्या होगा? Just C upon was observer तो yeah, observer stationary है, and अब source move कर रहा है. Okay, along C, which means like C minus V होगा यहाँ पे. Okay, that terms of the initial frequency. That's this frequency, right? Okay, तो ये गया this thing. C plus V upon C minus V minus 1 times F naught, right? That's our beat frequency, because F naught was the thing. So what do you get? Just 2V upon C minus V times F naught. Awesome. F naught is 492. This thing is like this times 2 times 2 upon 330. It is like 328. Okay, interesting. That should do it. Okay, 4 countable. That's just a 492. That's just 330, I believe. Okay, yeah. So it's multiple of 4. Like you have 8, and this is 2. Yes. So divide by 2, say. What do you get? It's like multiple of 4 as well over there. What's multiple of 2 now? Just 4, 1. और ऊपर आएगा 1, 2. So 8, फिर 12 के लिए 3. So 1, 2, 3 upon 4, 1. Which is 3, right? So just 3 is the beat frequency. 11th answer. Next question. 12. An isotope of iodine beta decays into an isotope of xenon with half-life of 8 days. A small amount of serum labeled with this is injected into the blood of person. The activity of the amount this thing injected is okay. So 131 iodine. Oh shit, we don't know. Wait, iodine का atomic number क्या है? We don't remember that. Okay, decays into xenon with half-life of 8 days. ठीक है ना? iodine it just becomes xenon with half-life. Beta iodine के बाद में xenon आता है, because like yeah. So all it has is that it has one more proton. So beta minus decay मतलब कि तुम्हारा जो mass है still remains the same, but तुम्हारा proton एक extra मतलब कि तुम्हें यहाँ पे एक इलेक्ट्रॉन मिलेगा and then plus एक एंटी न्यूट्रिनो. Okay, the small amount of serum labeled with this thing is and it has half-life. Okay, so T half जो भी है T half equal to 8 days. That's a big. Okay, the activity of a amount of huh? the accretive amount of the small amount of serum, okay, is known that what is BQ? I don't know. जो भी है. It is known that the injected serum will distribute uniformly in the bloodstream in less than half an hour. After this many hours, 2.5 liter of the blood is drawn to a person's body and given an activity of this thing. Okay. And it gives an activity of this thing. Total volume of the blood in person's body. Okay, that's actually not that hard. So, yeah, 2.5 in what? Liters, right? 25 times 10 power negative what? 4 or like 2.25 times 10 power negative. Like, yeah, 1 upon 4 जो भी है. I'm gonna do that 25 times 10 power negative 4 upon जो भी volume अपनी requirement है. Okay, that is the fraction that we have, and this times initial जो थी क्या कहाँ पे चला गया अपना, right? Okay, times e power negative t upon, okay, I should not do that. It's like 1 upon 2 times t upon t half, right? This thing is equal to, so यहाँ पे अपना रहेगा 115 pq और ये था 24 times, okay. So 115 upon 24 times 10 power 4, right? This should be the thing, of course. So what do you get? You get 2 power t upon t half is, oh, you just want b, of course. अपना t की क्या क्या है, कहाँ पे कर गया ये? Okay, less than half an hour, 11.5 hours. So हाँ ठीक है, basically 12 hours अभी तक पास हुए. So 12 hours upon a day is 24 hours, like half of a half life. Wait, नहीं 8 days है ना. So 8 times यहाँ पे क्या आ जाएगा? Oh god, yeah, basically 12 घंटे बाद, right? इसका हाफ लाइफ 8 days की है. That's big. Okay, 1 upon 16. तो ठीक है ना. Let's try to do it. 25 times 10 power negative 4 upon b is equal to, okay, this times it's equal to 2 power 1 upon 16 times 115 upon, this is so stupid though. This won't help. Just won't help. You may use e power x. Okay. That's simple. Yeah, okay, awesome. So it's just like e power 1 upon 16 natural of 2 and natural of 2 is 0.7. Okay, understood. Upon kita 24 times 10 power 4. Let's try to do it. What do you get? V equal to 2 power negative 1 upon 16, which is like close to 1 जो भी होगा. And what is this going to be? 5 तो हटे, just 5 यहाँ पे. This thing is 2 and 3. Okay. Wait, 23 नीचे. That's not what you want. 2.4. Okay. जो वॉल्यूम अपन ने इसमें डाली था जस्ट, ओके लाइक दैट. हाँ ठीक है ना. लाइक अप्रोक्सीमेट कर सकते हैं एक्चुअली v प्लस दिस थिंग. सो हाँ, v प्लस द सेम स्टफ ओवर देयर. ऑसम. जस्ट या आई एम स्टार्टिंग टू अंडरस्टैंड क्या हो रहा है यहाँ पे. सो अप्रोक्सीमेट अपने को वैसे भी करना ही पड़ेगा. देन 23 24 आई गेट इट, अप्रोक्सीमेटली वो सेम हो जाएगी. तो वो गया. इस स्थिति की व्हाट v इज इक्वल टू 2 power negative 1 upon 16 times 10 power 4 upon 5 times 10 power negative 4. So just 8 आ जाएगा ऊपर. It's just 2 power negative 1 upon 16 upon 5 times 10 power 8. Yes. So तो चाहिए it's in water. Sorry, oh, wait. कितना liters, right? Liters में चाहिए. Wait, liters. ये जो चीज़ थी ये कितनी थी? अरे यार ये काफ़ी सारे चले जा रहे हैं. What was the volume injected? 22.5 milliliters. 25 times 10 power negative 4, right? Yeah, exactly. So liters, it will just be this much. यहाँ पे तो 10 power 8 वगैरह तक जा रहा था. Just stupidly high. That doesn't make sense. We can't do it if that's the case. So that's the fraction over there. We should have really just worked out. Oh, sorry. Okay, that's not divided, but it's like multiplied, right? Of course. Of course it's going to be multiplied this thing. Okay, तो ये क्या होता है? It's just 5 times 2 power negative 1 upon 6. Okay, yeah, approximately that much. Or you could just do this times 24 upon 3 as well. It's getting complicated, isn't it? Yeah, -1 I have. Of course, liters per like it's much bigger than that. That's what we're assuming, at least. Right? I mean, that should not make a big difference. What if it does? What if it does? Whatever. So this is the modified oxidation. Or so yeah, let's do it. 25 or 23, sorry. So ठीक है ना? It's approximately 1. भूल जाओ इसको, just 1 plus 1 upon 23 जो भी है. What do you get? Like 5 times ये जो चीज़ है natural log of, so e power natural log of 2 times negative 1 upon 16, which is just negative 7 upon 160, I guess, right? E power this guy, which is approximately just 1 minus 7 upon 160. So basically what, 5 times of 1 minus 7 upon 160, and then ये जो 23 वाला factor है just yeah, it's 1 upon 23 or something. Oh shit, this actually matters a lot, huh? This does matter a lot. So approximately 1 upon 20 and then just like what do you get? 5 plus 1 upon 4. Ah, right. But yeah, okay. But wait a second, just 1 upon 4 minus ye cheese. 8 or something. Okay, it is actually close to 5. It is just close to 5. Right. So when's the answer? 5. That's it. Next question, 13. 13 is, oh, you don't get. Okay. 6 questions of matching type, 2 tables, each having 3 columns. Just do it. Okay. Electron with V vector given. Electron with V vector given. क्या है? Charge particle introduced in at origin with a given initial velocity V vector. Uniform electric field and uniform magnetic field exists everywhere. The velocity, electric field, and magnetic field are given in columns 1 and 2 and 3 respectively. The quantities E naught, P naught are positive magnitude. What? Okay, so E vector, U vector, uniform everywhere. Initial velocity V vector. Some direction we don't care कहाँ पर है. Okay, the magnetic velocity V vector. V vector. The quantities E naught, P naught. Okay. तो इसमें जो options में आता है. Okay. Which case the particle moves in a straight line with constant velocity. Yeah, it's like uniform motion. और क्या है? So first तो अपने को just वही करना है. Like force equal to 0. So what do you get? Q. Wait a second. What's I gonna do? Um, yeah, okay. Q times V vector cross V vector. That is supposed to be equal to Q times just E vector, right? Yeah, so force is 0 ho jayega in that case, which means that basically V vector cross V vector should be equal. Yeah, E vector is calculated as V vector cross V vector, right? That should happen. Okay. This कौन सा इसमें ऐसा हो रहा है? So first case क्या है? 3 to R. So 3 है. Okay, इसमें 2 आएगा ना? E vector equal to negative so around y hat. ये तो 0 हो गया यार. That's just not going to help. So third is just wrong because yeah, that doesn't actually help, right? Mm-hmm. I mean instantaneously, right? Instantaneously, yes, I suppose. Okay, और क्या है? B fourth one S. Okay, fourth one S. This might just help. So यहाँ पे E naught. Okay, इसका magnitude unit vectors. Okay, got it. Oh, this is in the Z hat direction. That won't help. That's not help. It's perpendicular that. C third 3R. Okay, no. Second third S. S कहाँ पे मरा हुआ है? Okay, X Y might make sense. So V vector cross E vectors like Y cross Z is actually just, it's not negative I hat, no, it's positive I hat, right? Wait, mess up somewhere. Oh, okay, it's 3 3 P. Wait, नहीं वो तो हो चुका है. Second 3 S. I mean, that's the only remaining one. हाँ, unless like E vector खुद ही 0 हो जाए, because ये अगर होना चाहिए then E vector must be 0. but that's not happening anywhere. Okay, so this with 3 here, that can't be a, yeah, that just doesn't actually make any sense. Constant velocity, of course. Okay, और क्या है fourth one S, we tried that, it doesn't actually help. Fourth one S, इसमें 2 का फैक्टर आ रहा है extra, which doesn't make sense. और क्या है 2 3S, that doesn't help because reactor cross, is that right? Y hat cross G hat is just X hat, of course. इसमें negative कैसे? Let's suppose like negative of this guy, so it makes sense. Oh, okay, plus, okay, that's too negative. Right, right, right. So you correct in fact. Second, third S. Okay, which is what? D. Okay, so this third answer D. Or क्या है? Fourth. Which case will the particle describe a helical path with axis along the positive Z direction? Axis along the positive Z direction, helical path. Yeah. So the Z component does not actually change, right? Yeah. X component does change. Wait a second. Oh, yeah, magnetic field should just be in the right. My electric field or magnetic field दोनों it should be in the, because it's circular चाहिए, then this should actually remain constant, which only happens if electric field has no xy component, right? Yeah. So your electric field and magnetic field should be in the z-hat directions. Awesome. The particle describe a helical path that axis along the positive z direction. Let's see. Fourth, okay, जब भी थर्ड आ रहा है वो तो मतलब I don't know, फर्क नहीं पड़ता ना. Yeah. 1s, okay, ये z hat में है and this is also along z hat. Yes. 2r, okay, no. 3, no. Second, okay, no. So a is the thing. 1s, yes. So fourth answer A. Next question. 15. In which case would the particle move in a straight line along the negative direction of y-axis, i.e. along negative y hat? Straight line along the negative direction of y-axis. Wait, 1 second, you're like, wait a second. Straight line, negative y. Oh, of course, like this happens if, wait, okay, wait. जो ये था अपना, कहाँ पे मर गया ये? 14 का आंसर A. तो A में fourth कहाँ पर है? Fourth is, thank God, x hat. Yes, that actually makes sense. Straight line along the negative direction of y-axis. Okay, awesome. So ये तो इसमें कहीं भी कुछ नहीं दिख रहा है because but इसमें कहीं भी negative y type कोई भी कुछ नहीं है, so ये doesn't make sense. If it has to move, it has to move like that, right? Unless, okay, third, maybe third is the thing. So ये zero होगा. Okay, then electric field is like negative. Okay, if magnetic field also working like that, that is actually works. So second, and then it should belong y hat, which happens in R. So 3 to R. So 3 to R is B. Next question. 15th answer B. 16th is, okay, ideal gas is undergoing cyclic thermodynamic process in different ways as shown. Corresponding PV diagrams, column 3 of the table. Consider only path from state 1 to state 2. W denotes the corresponding work done on the system. Equations and plots in the table have standard notations as used in thermodynamics processes. Have standard अलग अलग होते हैं chemistry physics में. Here gamma is the ratio of heat density as constant pressure and constant volume. Number of moles in gas is n. ठीक है ना, जो भी है. अभी करना क्या है? ठीक है ना. So कौन सा है? तो we just want only the path from 1 to 2, right? Okay, so 1 to 2 is just constant pressure, isobaric. So third ka P, so just start doing it, right? Okay, so we'll just start with P. P के लिए it's isobaric and also work 1 to 2. ठीक है ना, हमेशा 1 to 2 रहने वाला है. So what's the work done? Work done is just, PV2 minus PV1. Okay, that actually makes sense. Wait, okay, work done by the gas. It's just, yes, okay. Oh, wait, but that's negative of what's in physics, right? And work done क्या ऑन दी ओके, जैसे केमिस्ट्री नोटेशन यूज कर रहे हैं लोग, ठीक है ना। सो सेकंड इज करेक्ट, सो इसका सेकंड आएगा, पी का थर्ड एंड सेकंड। ओके, क्यू इज ओनली टू व्हाटएवर दिस थिंग इज, आई डोंट नो ये क्या प्रोसेस है। either it's adiabatic or isothermal. I believe it's isothermal because hyperbolic लग तो रहा है. So one or four, one or four. I don't know कौन सा है ये. ठीक है, I guess. It's kind of weird. Or maybe I should do this actually. Like, okay, so let's just do it in the other way. Small I. उसका isothermal के लिए just have fourth and कौन से और isothermal लग रहा है इसमें. Q can work, R can work probably. I don't know. Q R. या ओके, और क्या है सेकंड, आइसोकोरिक. आइसोकोरिक के लिए इट्स एस एंड वर्क इक्वल टू जीरो, सो थर्ड एंड एस. फिर थर्ड आइसोबारिक, दैट्स पी एंड वर्क डन इज सेकंड एंड पी. एंड फोर्थ एडियामेटिक, वन सेकंड क्यू और आर हो सकते हैं, आई डोंट नो. एंड देन फर्स्ट एंड क्यू एंड आर. Yeah, that should be the thing, of course. We want to be like working on the yes. Yeah, NCV delta T, that's why this thing. Awesome. And working on the system, that's why negative में. Zero. Okay, yeah, got it. Let's do it. The following is the only correct representation of process in which delta equal to pressure constant चाहिए, right? Which means isobaric, which is third. So this third से start करना चाहिए. Okay, ये तीन इसमें है ना. थर्ड का क्या है? थर्ड का सेकंड एंड पी, of course. So D is correct. 16th answer D. और क्या 17 which of the following is a correct combination. So second के लिए fourth and S, is that correct? No. Second के लिए third and S, yes. So B is correct. That was pretty obvious. Okay, और क्या है? Fourth के लिए 2 and T. Nah. Fourth के लिए हाँ ठीक है ना. Next. और क्या है? The following options correctly represent the chromatic process that is used as correction interpretation of speed of sound in an ideal gas. I guess that's constant pressure, right? Yes. Yes. Wait, yeah, I mean that is constant pressure, of course, because just to move ऊपर ले रहे हो, yes, it's constant pressure, which is once again just isobaric. So that's the same thing as this guy. कहाँ पे था इसका? और 16 का आंसर था अपना B, which is 2,3P. Okay, that's not here for some reason. It's not an ideal gas. फिर और क्या हो सकता है? Oh, you know कि वो like it's gamma P though, so pressure should be the thing, but then करेक्शन इन द डिफरेंस, आई डोंट नो तुम क्या बोल रहे हो. सारे जो करेक्ट है वो दे दूंगा जस्ट. सो क्या है? सेकंड का फर्स्ट एंड क्यू है क्या? नहीं. सो ये रॉन्ग हो गया. सेकंड का फोर्थ एंड आर है क्या? नहीं. फोर्थ का थर्ड एंड आर है क्या? नहीं. फोर्थ का फर्स्ट एंड क्यू है क्या? शायद से. सो डी इज करेक्ट. 18 का आंसर डी. क्या पता कौन सी बात कर रहे हो, बट दिस इज द थिंग. ओके, oh yeah, that's done now. Just do chemistry properly now. Okay, 54. कम क्वेश्चन इसमें, 18 तक दिए. ओके, आइडियल गैस एक्सपांडेड फ्रॉम P1 वो अपन कर चुके हैं, राइट. करेक्ट स्टेटमेंट about offices this there are central atom in both is sp3 hybridized HClO4, huh? And HClO you get 2. Okay, so HCl, okay, HCl and the HOCl रहता है, which is just यहाँ पे OH and that's like a Cl, फिर यहाँ पे ClOH. अब मेरे को चाहिए है O2, so एक और O, और फिर यहाँ पे है Cl 4 O. Okay, like this. Okay, got it. Central atom in both is sp3 hybridized. इसमें क्या है? 2 इलेक्ट्रॉन जोन्स ऐसे ही आ चुके हैं. वेट अ सेकंड, क्या हो रहा है इसमें? अगर पाई बॉन्डिंग इलेक्ट्रॉन अपन नहीं लेते ना. यस. सो तुम्हारा एक पाई बॉन्डिंग इलेक्ट्रॉन तुम नहीं ले रहे हो, तुम्हारे से Cl में 7 है, तुम्हारे से 6 बचे हुए, 6 प्लस 2 इसमें डाल रहे हो. 8/2 is just 4 इलेक्ट्रॉन जोन्स एंड 2 तो ये. ओके, 4 is like sp3 of course. So A is correct. Oh wait. और ये भी, हाँ, इसका टाइम देखना पड़ेगा. वन सेकेंड, एक दो तीन तुम इलेक्ट्रॉन हटा दे, लाइक फोर इलेक्ट्रॉन्स हमारे पास में रहेगा सिग्मा बॉन्डिंग के लिए, इसमें और क्या डाल दो, चार इलेक्ट्रॉन्स ऐसे इसमें डाल दिया पॉइंट टू सेकेंड, वन सेकेंड फोर, सो दैट्स आल्सो sp3, सो यस, ए इज करेक्ट, most likely incorrect because वो कहीं ना कहीं अपने को incorrect करके देगा. HClO4 is more acidic than HClO because of resonance stabilization of its anion. I guess yeah, because इसमें बड़ा resonance system है, so हाँ, mostly इसमें charge का रहता है, but I guess you could say so. So B is also correct, right, right. 21 का B correct है. और क्या है, HClO4 is formed in the reaction between Cl2 and H2O. नहीं, उसके उससे अपने को HOCl मिलता है, then you have to like oxidize that. No, not so easily. Conjugate base of HClO4 is weaker base than H2O. Conjugate base of HClO4 is ClO4 minus. It's weaker base than H2O. I have no idea. But वो charged है, it should be a stronger base. Right. So 21 का अपन क्या कहते हैं? Next question. Color of X2 molecules of group 17 elements change gradually from yellow to violet in the group. This is due to physical state of X2 at room temperature changes from gas to solid down the group. X2 molecules of group 17 का क्या कलर चेंज हो रहा है from yellow to violet. हाँ, I don't remember what was the reason. Physical state of X2. Okay. I guess maybe C is something like homolymph gap, right? Yeah, वो decrease हो जाएगा. Energy of down the group. I don't think that's the thing. क्योंकि इलेक्ट्रॉन ट्रांजिशंस कर दें, अपने को आयनाइज नहीं करना डायरेक्टली. हाँ, हो सकता है ए करेक्ट हो, आई डोंट नो. ओके, जस्ट मूव ऑन. Addition of excess aqueous ammonia to pink colored aqueous solution of blah, okay, which is out of the presence of air in the aqueous solution complex Y behaves as 1,3 electrolyte. The reaction of X with excess HCl at room temperature results in the formation of blue colored complex Z. Okay, I don't know इसका actually. Excess ammonia to a pink colored aqueous solution of MCl2.6H2O gives the octahedral complex Y in the presence of air. Okay, I don't know this happened, so I won't do this. IUPAC name of the following compound. Okay, it's like toluene, right? So 1, 2, 3 para-toluene. Okay, one nahi, 4 fluoro methyl. Oh, okay, you don't. But toluene तो रहता है यार IUPAC में. Or is that was not the thing. I don't know. Is this methyl benzene or it's no? It must be toluene. Of course, it should be this thing. Right? It's not a group. It's actually. Hmm. I don't know. Toluene is used, right? It's used in IUPAC nomenclature. So I think B is not that wrong. I still don't know. So we'll just move on. Correct statement of the following addition reaction is on R. Br2CHCl3 for this guy is M and N. CHCl3 is like, okay, that's weird. कहाँ पे देखा ये अपन ने? देखा तो नहीं लग रहा मुझे. Like, okay. Hello form, but उसके लिए अपना NaOH लगेगा ना? CHCl3. You could just pluck out those guys or something. Most likely bromination है और कुछ नहीं है. Is it? हाँ, I don't know. Okay, man. और ये क्या है? Br2CHCl3 is O and P. Right? Bromination ही होगा, and most likely they're using this as a solvent. जो भी है. O and P are identical molecules. No, they are not. They are stereoisomers. M and O and N and P. तो ये correct statement, right? Okay. M and O and N and P are two pairs of diastereomers. Yes, diastereomers because एक are yeah, okay, that explains it. हाँ ठीक है ना. M and O and N and P are two pairs of diastereomers. Wait. Oh, like M is diastereomic with O and N is diastereomic with P. So yes, actually that's right. M and O and N and P are enantiomers. No. Bromination proceeds trans whatever. B is correct. 25 का P correct है. और क्या दिया है? Bromination proceeds through trans addition in both the reactions. नहीं रे, syn addition होता है ना. Of course syn addition. I mean, what else is there? It's just normal Br2 उसमें attach करेगा और क्या? Or is it like radical magnetic? don't think it can be radical mechanism. Any case, yeah, any case diastereomers बनने वाले. If we have it's like trans, ऐसा ही होगा. Okay, whatever. ये तो अपन कर चुके हैं. Number of sum of the number of lone pairs of electrons on each central atom with the following species. Wait, कितने बचे इसमें? 28. हाँ, काफी सारे बचे. The following species. Atomic number n equal to this thing, f equal to this, blah blah blah. किसी number of lone pairs of electrons on each central atom in the following species is. So, okay, number of lone pairs. Okay. Central atom, of course. ठीक है ना? TeBr 2 minus. It's gonna be some bad thing going on. At least for bromine, okay, it's like a halogen sister, that of course. और ये सब क्या है? NSF3. Ooh, not going good. NF3. Okay, so Lewis structure बनाने का ट्राई करते हैं. Terilium Br6 is just that order. ठीक है ना? Terilium क्या है? What's its atomic number is 52. लिखो इसका टेरिलियम का इलेक्ट्रॉन कॉन्फ़िगरेशन लिस्ट. 2s2 2p6 3s2 3p6 4s2. ओके, कितने हो गए इसमें? 8 प्लस लाइक 10 10 प्लस 8 18 अभी तक हो चुका है. ओके, अभी तो काफी जाना आप लोगों को. 52 तो चला है. ओके, 3d10 then so 4s2 3d10 probably just like 4p6. Okay, and then what was the thing after that? All right, 5s2. All right, that was the thing. So चलो करते हैं. कितना है ये? 10 हो गया. This thing is 8. This thing is 10. यहाँ पे 8 है, right? So combined is like 20 and 36. It's still just 36. You want this to be 52 or something, right? That's very, yeah, okay. चलते जाओ. हाँ. Okay, no, this 6 over there, and ये जो चीज़ है just 4 plus 1 like 5. Okay, this still going on. चलो फिर और क्या अगला आने वाला? just fold D10. So D के लिए क्या? just 2 plus 4 6, which is okay, it's good enough with that. फिर next आएगा F, right? Yeah. So like wait, 34F probably something or like 5S हो गया. 6S के लिए क्या? 6 over there, and F के लिए. Oh right, so 4F not possible yet, right? So just go to 5 हो गया. 6S. Oh नहीं, पहले we'll go to 5P, right? Yes. So 5P. That makes sense. तो कितने हुए अभी तक? 10 8 10 8. यहाँ पे एक और बार 10 6 over there. Next आएगा 6s2 because clearly the next चीज है which is like 4d10. That's just 6 over there. 4d, that is 4f, which is 7. काफी बड़ा होगा. So you have to go to 6s in that case. Yes. So इसमें combined 8 आ जाएगा. Let's see कितने होंगे अभी तक. 10 10 10 30 30 plus 3 minus 24 20 54. Okay, that is 54. Tellurium. So just 5. Okay, got it. So इसमें 6s2 रहने वाला है, right? So इसकी outer electronic shell क्या रहेगी? 6s2 and then 6p remaining है. Okay. Weird. Yeah, that should probably do it. इसके ठीक बाद में लेकिन d orbitals आते हैं नहीं? हाँ. Very weird. Anyway, number of lone pairs of electrons on. राइट, तो 6 जो है ऐसे वो लास्ट वन. 5 अपन पूरा यूज कर चुके हैं, राइट? नहीं, 5d अभी बचा हुआ है. सो नॉट गुड. पेयर ऑफ लाइक, या ओके. वेट, दिस इज अ वियर्ड थिंग. इसमें d भरा नहीं है. सो हाउ डू आई इवन, व्हाट डू आई इवन मेक आउट ऑफ इट? पहले d शेप को तुम भरो, राइट? यस दैट थिंग. इट्स लाइक अ कॉम्प्लेक्स ऑफ कोर्स. तो पहले तुम d शेप को भरना पड़ेगा, राइट? So इसमें दो आएंगे डी शेल्स, like what 5d or something, right? Whatever. इसमें तुम्हारे जो डी शेल्स 10 आएगा and then so 2 minus, so put that in there. ब्रोमीन इसमें या ओके इट्स लाइक 6 तो आ रहा है ऑलरेडी, जस्ट 2 प्लस फिर 2 इसमें टेलुरियम 2 माइनस में ओके एंड देन प्लस 6 बिकॉज ब्रोमीन या guess that's the thing, but it's a complex, so should we even take the 6 in there? आपने को फिर सम करना है, सबका निकालना पड़ेगा नहीं? These complexes tellurium Br6 huh? It's just so stupid. एक सल्फर के जैसा है ये नहीं, इसमें लास्ट में 6 इलेक्ट्रॉन्स रहेंगे and then yeah, but how is that the case? How can this be 6 electrons? That doesn't actually make any sense. 54 you are saying, this is 24 times plus 30, that is the thing sure, but ये कुछ और ही दे रहा है, ये कुछ और ही दे रहा है नहीं? Should have like 6 electrons in there. ये कैसे हो गया? I'm missing something. Yes, I am missing something. But क्या? Just 8 over there. They should just have. It's gonna take too much of time. मुझे नहीं पता इसको कैसे करते हैं. तो पता है, but like ये थोड़ा सा complicated है. Tellurium. Just go with it. Like 2 plus 2 plus 6 is number of electrons upon 2 is just 4 plus. Okay, 5. 5 lone pairs. I'm gonna assume that. I don't know correct है कि नहीं है. Or which is around like 6 plus 6, which is like 12 or 2, which is 6. Yeah. तो यहाँ पे 2 electrons missing है for some reason, I guess. Tellurium, iodine, and then xenon. It's different. It's different. ठीक है ना, whatever. Just this thing. Uh, it's got a thing like yeah, 5 plus फिर BrF2, right? Like bromine just has 7 फिर 7 plus कितने F2, okay, like 9, 9 upon 2. Oh wait, bromine is like that. Oh plus, right? Okay, got it. Wait, but then usually it's like you just go by the fact that tellurium S sub like O family का, that just means कि यहाँ पे 6 होने चाहिए, like 6 plus. Oh, that's different result in that case, like 6 plus 2 plus 6 upon 2, which would be a different thing. हाँ, I guess you just have to go with that logic. although थोड़ा सा अजीब है. ठीक है ना, who cares? 6 plus 2 plus 6 upon 2. It's just so stupid though. 6 कैसे हो सकता है? It's clearly कि यहाँ पे P4 भी नहीं है. That doesn't actually make any sense. Unless तुमने ये कुछ अलग कर दिया इसमें, then 52. Oh, okay. It's like okay, just 5 pieces over there. You should have told me. It's 52, not 54. 54, that's xenon. Right. So combine the 30 plus 16, which is still not there actually. Okay, that plus is of course, which is 4p6%. No, that's like 52, of course. Just 5p6 are last one. That's weird. So, okay, 5 has 2, 5. Okay, that explains it. But shouldn't that be xenon? Xenon should be 52, right? Or not? Wait. What am I doing wrong? Just 10 plus यहाँ पे फिर 8 आएगा, फिर 3d10 के लिए 10 है, फिर 4p6 है, उसके लिए 6 आएगा, and then you got 4. What is going wrong? I'm missing something. 4d is 5, यहाँ पे 5 है, this thing is 6, right? Yeah. So 5 and 6 से भर गया है. That's the thing, of course. इसमें 8 electrons in the lower. ठीक है जो भी है. And this should be 52 though. So what went wrong? 1s2 कहाँ पे मर गया? Okay, that explains it. shit. Okay, this is xenon. Okay, got it. So like actually P4 आएगा. That is the thing. Yes. 6 electrons and वही तो बोले थे इसमें कैसे कंफ्यूजन कर रहा हूँ. तो यहाँ पे क्या? This is just 6 electrons फिर प्लस यहाँ पे 2 electrons आ जाएगा. Because yeah, फिर प्लस 6 फिर प्लस ब्रोमीन के 7 फिर प्लस minus 1 like okay, 6 यहाँ पे जाएगा 6 and then फिर प्लस F2 like 2 उसके बाद में प्लस SN जो भी है। सो नाइट्रोजन 5 इलेक्ट्रॉन्स, फिर सल्फर की वजह से 1, तो वजह से 3, जो भी है, और नॉट। वेट, डबल बॉन्डिंग तो नहीं हो रही ना इसमें? ना, इट्स गॉट बी, दैट्स कॉम्प्लिकेटेड इजंट इट? या NF3, that won't work, that is more work. You need 2 sulfur, okay okay, समझ रहा हूँ, like this thing, and प्लस आएगा फिर यहाँ पे S माइनस, राइट? सो एक इलेक्ट्रॉन कम करना पड़ेगा, एंड देन यू गॉट दिस F3 गाइस। ओके, तो एक इलेक्ट्रॉन कम किया और फिर एक इलेक्ट्रॉन भागा, राइट? सो 5 माइनस तक 4, 4 प्लस फिर 4, राइट? यस, एंड दैट प्लस ये चीज which is like it just has 8 electrons, is that right? Yeah, 8 electron, फिर क्या, फिर प्लस 3 and then plus 1 and all of that upon 2, right? चलो करो, 6 plus 2 plus 6 is like, कितने 6 में 3 times of 6, फिर 2 कितने आया, just 2 times of 2, फिर 4 plus 3 plus 1 plus 8. Interesting. This is just 4 over there. Like this is just 8 plus 8, 16, 16 plus this like 16 plus 4 is just 20, 20 plus 18, which is, and then upon 2, of course. So it's what, 10 plus 9, 19 electrons. Oh, 19 lone pairs. So 28 cancel 19. Most likely incorrect, but then whatever. 29. Among these guys, number of magnetic species is. इसमें पक्का आपने कुछ, ओके ये तो मुझे नहीं आता है करते, या देन दैट्स राइट, ओके ठीक है ना। फिर कहाँ पे थे अपन? among these guys number of diamagnetic species is H2 He2 plus Li2 Be2 B2 C2 blah blah blah, diamagnetic species। हाइड्रोजन का हाँ बहुत पता है अपने को। So is H2 diamagnetic? I mean it is. It is, right? Yeah. He2 plus. That's kind of weird. So we don't know the orbital. Oh god, no no no. Wait, 1s2 and 1s2 combine किया है, just 4 इसमें ऑर्बिटल साइकिल, एक ऊपर है then एक नीचे है सीधा पे, राइट? इट्स लाइक दिस थिंग, एंड देन तुम्हें क्या है, इसमें जस्ट प्लस आ रहा है, इट्स लाइक 3 electrons and 2, okay okay, weird, that's what's happening. Is this, no, it's paramagnetic of course, and H2 that was diamagnetic, okay, so H2 is diamagnetic, Li2 3 रहेगा ना इसमें, okay, that's like, oh yeah, okay, वो तो फिल हो चुका है, जस्ट तुम्हारा p ऑर्बिटल स्टार्ट होता है, राइट? ओके, सो फर्स्ट तुम क्या फील करते हो? सिग्मा बॉन्ड ऑफ कोर्स, हाँ पहले 3 तो ऑर्बिटल्स ऐसे रहने वाले, जस्ट Li2, या इट इज नॉट लाइक दैट, हाँ ठीक ना, इट्स जस्ट, इट्स डायमैग्नेटिक एज वेल, सो Li2 वर्क्स, Be2, और दो तुम बॉन्ड डाल रहे हो, इट्स लाइक, ओके दिस इज पैरामैग्नेटिक, B2, राइट? तो और दो डाल दीजिए, जस्ट सी दिस थिंग, दैट्स डायमैग्नेटिक, सो B2 वर्क्स, C2 that I believe was paramagnetic, right? Because, or was it not? Next जो आएगा it's just, right, नाइट्रोजन तक रहने वाला है, उसका हमें फ्लिप हो रहा है, राइट? ओके, सो पहले ये एक सिंगल नीचे आता है, which means oh it's diamagnetic as well somehow, और फिर N2, तो N2 is paramagnetic, and then फिर में, उसके बाद में क्या आता है? फिर आता है O2, okay, wait a second, something went wrong, it's like 3 over there, ये तो ऑलरेडी नाइट्रोजन आ गया ना? The carbon would be when you have 2 of these guys, I guess. Something is not going correct. H2 is diamagnetic, yes. He2 plus is paramagnetic, that's what we did. Li2 plus, okay, Li2 is just diamagnetic, okay. Be2, paramagnetic, okay. I'm missing something. 2 plus, that's very filled, of course. Okay. Oh, इनमें से कोई एक ही fill करेगा. Okay, okay, okay. That's why B2 is okay. That's pretty obvious. फिर B2 should have this. The carbon should have 4, right? You should have 5. Like, okay, 3. So ये, wait, am I missing something? It means like 3, तो once I start करते हो यहाँ पे, okay. Then for BE2 just have 2 and 2, so 2 custom split किया, just that. ये, yeah, well, Oh shit, wait. इसमें दोनों ऐड करते जाते हैं. 3. Wait a second. That's B2, right? Yes, that's right. Okay, B2. Of course, that's the thing. फिर C2 में ये आएगा, so it's like diamagnetic. Okay. Then N2 में just have these guys. So this is paramagnetic, and O2 में flip होता है. So that's why um, ये भर गया. फिर ये आएगी, right? So इसमें अपने को क्या क्या बनना है? Well, O2 should not have this thing. It's like 3 यहाँ पे आ रहा है. It should be just 4, so 4 should be filled up. 4 तो already आ चुके हैं. हाँ, कुछ जल्दी नहीं हो रहा, थोड़ा सा ज़्यादा ही कुछ जल्दी हो रहा है, नहीं? Yeah, so like बोरॉन में 3 था, कार्बन में 4 था, right? Yes. Wait. I'm missing something. बोरॉन 5 है, उसके तुमने 2 हटा दिए because 1s2. 2s2, 2s2, मैं भूल रहा हूँ उसको. Yeah, that explains it. So, right. Li2 plus is like that. Okay, that's diamagnetic for sure. फिर okay, तुमने Li2 का कर दिया. फिर तुम्हें next आएगा Be2, which once again just diamagnetic actually. So H2 Li2, Be2 is in fact diamagnetic. And what about B2? So next यहाँ पे आएगा, okay, ये चीज, right? So B2 is also diamagnetic basically. Okay, and then there's C2, which, oh, it's actually paramagnetic, huh? Yeah, okay, C2 is paramagnetic. Weird. उसके बाद में आता है N2, which is diamagnetic. N2 is diamagnetic. And then there's O2, which is in fact wait, O2 minus. Okay, that's also just paramagnetic, so वैसे भी जाने वाला था. Right. And then you got F2. Oh, इसमें H2 plus भी आएगा ना? Okay. He2 plus. Okay, फिर H2, फिर Li2, Be2, B2, C2 is diamagnetic, right? Wait, no, it's paramagnetic actually. C2 is paramagnetic, N2 is there, and then O2 minus is paramagnetic, and F2 is, for F2 just have 1, 2, 3, 4, 5. Right, 5 electrons. Yeah, 5 electrons, of course. Because 2 already के साथ. Yeah, okay, so that's just 5 electrons for it. And actually that is diamagnetic, right? F2 is, wait, is that correct? 2 minus over there, that's just paramagnetic. F2. Yes, it is. F2 is diamagnetic, huh? Okay, F2. Awesome. So कितने? 1, 2. Oh, okay, like H plus is actually paramagnetic. That's why we don't have it. फिर 1, 2, 3, 4, 5, 6, right? Okay, 29 का answer 6. Next question, 30. Among the following number of aromatic compounds is, this is actually हाँ ये flip, okay, it actually bends, right? तो ये नहीं है. I guess that was a thing. Yes. This is वैसे भी नहीं होगा ना, वैसे भी नहीं होगा इनफैक्ट. ये चीज नहीं, ये चीज हाँ, सिंगल, सो यस इट्स करेक्ट. सो ये राइट, या ओके, ये चीज नहीं, ये चीज यस, तो ये और ये नहीं, ये हाँ. सो 1 2 3 टिल नाउ. दिस गाय नो, दिस गाय ओके. ये कॉन्जुगेशन में है क्या थ्रू आउट? ओके, दिस कैन एक्चुअली बॉन्ड. ओके दैट्स फाइन. वैसे भी अगर नहीं भी है then it's like still has aromatic rings in there, so that's right. Oh, this also has aromatic rings. Okay, that's also aromatic. Okay, so ये भी है, ये भी है. 1 2 3 plus 1, it's still odd numbers. Awesome. 1 2 3, I mean yeah, 1 2 3 4 and 5. 30 का आंसर 5. Next 31. Matrix match. Okay, करना ही पड़ेगा नहीं. ओके, वेव फंक्शन इज अ मैथमेटिकल फंक्शन व्हिच डिपेंड्स, ओके, स्फेरिकल पोलर कोऑर्डिनेट्स ऑफ इलेक्ट्रॉन satisfy the quantum mechanics. R is distance of from nucleus, that is the co-altitude. हाँ पता है ना. In mathematical function, in the mathematical functions given in table, Z is the atomic number, A naught is the core radius. Okay, फाइन. सो वन एस ऑर्बिटल स्पेरिकल सिमेट्री चाहिए अपने को. इज लाइक वो phi n l m दिया है. वेट, राइट, ओके. तो तुम्हें r का फंक्शन मिलना चाहिए एंड नॉट ऑफ थीटा एंड फाई, राइट. सो कोई भी s ऑर्बिटल है देन यू डोंट हैव थीटा एंड फाई, बट इसमें थीटा है, सो इट कैन बी लाइक p और d ऑर्बिटल्स, राइट. या और ये क्या है रे? ओके. ग्राफ ऑफ दिस guy, probability density at nucleus is proportional to 1 upon a cubed density, right? I don't know what you mean by that. Okay, the correct combination for any hydrogen-like species. Hydrogen-like species. Oh, so एक ही है ना. one s, one s, and then if it's one s, it cannot be this thing. Might be this thing actually. E power negative z upon, okay, a naught. It's like z naught. A की power 3 upon 2. Okay. Z upon a. Wait, what is this thing? Okay, that's r over there. Fine. Guess this could work. One radial node. No node. कोई radial node नहीं इसमें. XY plane is a nodal plane. No. So one का 2 या फिर 3 या फिर 4 तो नहीं हो सकता. In that case it can only be 1, right? Yeah. So इसका 1 आएगा because कोई और तरीका नहीं है. Probability density at nucleus is proportional to 1 upon 8 naught की power 3. I don't know. So at nucleus, like as r approaches 0, this just becomes like, okay, it is a naught ki power 3 upon 2, not 3, in fact. Yes. So Q is wrong. Energy needed to excite like n equal to 2, n equal to force, it is 6 times energy. 2 to 6 state. Okay. ठीक है ना. What do you get? Like 1 upon 4 minus 1 upon 16 upon 1 upon 4 minus 1 upon. Okay, वो 2 के फैक्टर हटा देना. Just 1 minus 1 upon 4 upon 1 minus 1 upon 9, right? It's like, yeah, 3/4 upon 8 upon 9, which is 27 upon 32. Yes, so S is correct for this guy. So 1 S, which is not there for some reason. One radial node, I don't think that's right. और क्या, और तो कुछ दिया ही नहीं यार. अच्छा, 2s orbital. Okay, maybe I don't know. हो सकता है ना. So let's say the nucleus is this guy. Once again, s orbital है, so it's not even a phi or right. So इसमें फिर one radial node आएगा because yeah, most likely. So 2 and s, yeah, s तो चाहिए अपने को because that's maximum at the nucleus. I have no idea ऐसा क्यों हो रहा है. This is basically probability density, right? That's a phi value. Yes. You just got this thing. Okay. Phi is a function of r, which is going like this. So 1 to s, is that correct? No. Is 4 r correct? 3d z square orbital for a hydrogen-like species you are saying. So I don't know. Hydrogen-like species, god. Okay, r is I don't know. I don't know. Okay, or क्या है 2p. So 2 is just this thing and you want 2, 1 radial node, yes, and then p looks correct to me, right? So c looks correct. 31 का c. और क्या है? For hydrogen atom, the only correct combination is hydrogen atom, the only combination. 1 okay. 1 s is, so okay, s is correct. I mean, yes. But is 1 correct? Yeah, it looks like that. And 1 s orbital, I guess. Yeah, okay. 2 1 q. Wait, 3 में 1 नहीं था ना. 3 3. Okay, thank god. Wait, no, sorry, 2 2 p. Okay, got it. 2 में तो 2 चाहिए रहेगा. 2 1, I don't think that's correct. इसमें radial nodes नहीं आ रहे because look at this guy's derivative though. So ये तो कांस्टेंट रहेगा ऑफ कोर्स. इसके आगे जो c पावर नेगेटिव, या ओके, दिस ओनली बिकम्स 0 एट इन्फिनिटी. सो ये तो कुछ मतलब नोड्स आए नहीं इसमें. एग्जैक्टली. That's probably not correct. Okay, so you can't have 2s and 1 in anyways, like, so ये तो correct नहीं है, then 1 and 1 possible है. P does look correct. Wait, ये negative oh shit, how is this going to negate? Okay, so it's not correct. So जब P था, okay, so it's not C, थर्ड वन का C नहीं है यार. ये कितना लंबा हो रहा है. 2s, it's not having radial nodes, I'm telling you. Energy needed to excite electrons from any group. S is correct, but then 2 is not. फिर 4 4s, sorry 4 4r. I don't know, so कैसे करना है. 3, I have no idea. Because hydrogen atom केवल आते हैं ना. फिर second 2p. Apparently, oh okay, no, it's correct because second, right? इसमें yes, there's one point where it's like 0, so that actually makes sense. Sure, it's for 2s. So it is correct. 31 का C correct था. और के 32 का for hydrogen atom, the only correct combination is. So हर इसमें 1 आ रहा है. Okay, 2 2 2 1 2 1 wrong है. Okay, 1 1 S 1 1 is correct. Okay, and then you want S. Yes, that's correct. 1 1 P, no. 1 4. No, okay, that's wrong. So 1 1 S, which is A. 32 का A. 33 is आप मर गया. 33 for He plus atom, the incorrect combination. 1 1 R 1 1 R, that is actually correct. 2 2 Q, I don't know, but maybe I don't. 1 3 R. Okay, 1 3. Oh, so this is 3 yeah, no? Okay, it's like 1 3 is already wrong, which means that C is correct. Okay, so we can answer C. Just R. Yeah, 1 1 S, and that's obviously correct. Yes, yes, yes. Okay, next. For the synthesis of benzoic acid, the correct combination is benzoic acid. Okay, so toluenes में benzoic acid निकालना है. Just oxidize करा दो, right? Yes, so NaOH Br2, carboxylation, substitution. Carboxylation looks like a good thing. Okay, allophone. हाँ शायद से substitution, condensation. No, no, there's no substitution. Carboxylation, which NaOH Br2. That's for hello form though. Br2HB, that's for substitution. Hmm. What is this thing? It's like an ether though. Ether and then you have an acid. I don't know ये क्या कर रहा है. NaOH CO2. हाँ. Benzoic acid we are using. Okay, कोई और इसमें है. Acetophenone. How was acetophenone? Bromophenone was different. Acetophenone was something different, right? Okay. Was it just? God, I don't remember anything. Acetic acid. Just aceto. And then just have phen. But on कहाँ पर है? I don't know. Whatever. Just a ketone basically, right? Oh, ketone. That's fine. Got it. So इससे अपने को चाहिए है benzoic acid. Yes, still oxidation is the best way to go. Going this okay. KMnO4 वगैरह है नहीं इसमें, so you can't actually just oxidize this thing. In this case, it won't happen. Benzaldehyde. That's something that you could probably use. So NaOH Br2. No, wait, no, no, no. और क्या है? NaOH CO2. Carboxylation. Br2H3. So just that is brominating the whole thing. That's just stupid. That's not going to work. Aldehyde to ketone, aldehyde to acid conversion, right? You need like an oxidizing agent. ये oxidizing agent नहीं है. Can't be the case. No. Oh, okay, 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 okay. Acetophenone. Okay, you can use for yeah, you can use hello form reaction. So for that, you just need NaOH Br2, right? Exactly. That works. That works. So second का first, and then it's just hello form. So S, second first S. So 34 का A तो correct लिखा है मुझे. और क्या है? करेक्ट कॉम्बिनेशन. ओके, फोर्थ टू फिनॉल से अपने को चाहिए बेंजोइक एसिड. व्हाट डू यू डू? You can't get. Wait, So CO2 अगर यूज करके you can actually add that, but then फिर तुम्हें वो OH को निकालना है. How do you even do that? I don't think that's doable. मतलब सिंगल स्टेप में तो नहीं होगा. The only correct combination that gives two different carboxylic acids. हाँ. Oh अच्छा दो प्रोडक्ट्स मिलेंगे. Something like that. Okay. 2,4R क्या दिया है? Acetophenone, NaOH CO2. Weird. NaOH CO2. This is for phenol though. तो ये कैसे? Okay. I don't think that's correct. Fourth, third R. Fourth. Oh, sorry. Two का fourth था ना? That was the thing, of course. यार NaOH CO2. Fourth, third. C3COK. ये अजीब होते जा रहा है अब. C3COK. Okay, that's already there. Like anhydride and हाँ. I have no idea. Third P. Benzaldehyde. And this guy. What does that even do? C3COK you are saying. ये तरीका सा है क्या ये? And it's also using this anhydride. We were like oxidizing that. Substitution? Something like substitution? Maybe. ARSN? No, not probably going to work. We don't know about that. Okay. और क्या है? Fourth, third Q. We know that is not the thing. Okay. Carboxylation, huh? For that you just need this thing. So fourth चाहिए इसमें. Third P. I don't know क्या reaction है. 1,1S. Haloform reaction on toluene. Never seen that before. मुझे नहीं पता क्या होता है इससे. NaOH most likely just brominate हो जाएगा वो पूरा. I don't know. What is this? That doesn't look correct. So मुझे नहीं पता इसको कैसे करते हैं. The only correct combination which the reaction proceeds through a radical mechanism is Br2HQ, of course. So this is second चाहिए. Okay, toluene. Yeah, that works. So just R substitution. Yes. So that works. D is correct. So this is D. और क्या दिया है? 3 or P. Benzaldehyde and condensation. I don't think that works. Wait, condensation. Interesting. But कैसे? How do you even do that? Like, I don't know. Two different carboxylic acids though. किसने बोला कि वो carboxylic acid group अटैक होना चाहिए रिंग को, right? So let's actually do it that way. So condensation, huh? Benzaldehyde, and then you're using this guy probably. Just, or you could just use phenol, right? Mm-hmm. So anhydride we're just using. Okay, very weird. It's usually used for like acylation or something like that, but वो नहीं कर रहे तुम. ठीक है. CHCC minus over there जो भी है. Using this guy, then just attacking that. Okay, यहाँ पे just this is so stupid. You can't just kick that out, unfortunately. That's not going to work. Okay. There is charge over there or something like that, right? Mm-hmm. That's gonna make more acetophenone. That's not even what we want. That doesn't help. Doesn't help. So ये तो नहीं है. Fourth, third, Q. Okay, this is just stupid. अब मैं इसमें time waste कर रहा हूँ. Okay, पेपर तो हो गया. जो नहीं आया वो जरा उससे विजिट करते हैं. So first question physics का. Flat plate is moving normal to the plane under constant force F. Gas is kept at a very low pressure. The speed of the plate is V is much less than the average speed U of the gas molecule. So the following is correct. Pressure difference between the leading and trailing faces of the plate is proportional to UV. How do you even do that? U times V. Why is that the case? Okay, the average speed of the gas molecules. Huh? How is that important? Wait. Okay, नहीं मुझे नहीं पता. Thermodynamics in some way, I don't know. It's basically just fluid, but सारे वो जो equations like that just complicated, right? Yeah, steady state and whatnot. Think यार, what would you do to actually? अभी ये कुछ के कुछ है. I have never seen this before. External force F paralyzes the resistive force. At a later time, the external force paralyzes the resistive force. Yeah, I mean, eventually वो constant speed से move करना चाहिए, right? Yes, because resistance बढ़ता जाएगा in the end. So I guess D is correct. The plate will continue to move with constant non-zero acceleration at all times. I don't think that's correct. The resistive force experienced by the plate is proportional to V. Yeah, most likely जो drag वगैरह होता है वैसा ही है ना. Or yeah, I guess that's the thing. So B is correct. D is correct. Because अगर A है then it's correct. It's like B and D. Cool. So first answer B and D. Okay. I don't know about A. मुझे नहीं पता इसमें कैसे करते हैं. Anyway, तो that's done. मैथ्स के मेरे सारे हो गए. Okay, फिजिक्स में सारे हो गए. केमिस्ट्री के जो बचे हुए स्टार्ट कर लेते हैं. केमिस्ट्री क्वेश्चन 22 ट्राई करता हूँ. 22 क्या है? 22 कलर ऑफ H2 मॉलिक्यूल्स. ओके, ये तो थ्योरी बेस्ड क्वेश्चन भी पता. Gas to solid down the group. Is that happening actually? It teaches from gas to solid. Yes, actually it does. It does. Usually that's ही होता है सभी groups में. Yes, as you go down, वो solid बनते जाते हैं, right? Yeah. Okay. So we don't know about this one. Addition of excess ammonia in color solution of MCl2.S6H2O and NH4C is an alkyl complex in the presence of air. Ammonia डाल के, right? Okay, so fine. In an aqueous solution, the complex Y behaves as 1:3 electrolyte. What does that even mean? 1:3? किस चीज का रेशियो है? Reaction X is excess HCl at room temperature. Okay, X को अपन रिएक्ट करवा रहे हैं, मतलब बेसिकली ये चीज, राइट? या मतलब ये चीज with excess HCl results in formation of blue colored complex Z. The calculated spin only magnetic moment of X and Z is this thing, whereas it is 0 for complex Y. मेटल क्या है वैसे, ये कौन सा मेटल है, राइट? Probably copper or something because blue color. So हाँ, हो सकता है ना, right? Octahedral complex Y. So here, huh? In the presence of air, you are saying. That's weird. One is to three. Like I don't know what that means. 1:3 electrolyte. What are you talking about? It's like three तुम elect. Okay, तुम three ions की बात कर रहे हो or something like that. Because दो Cl आएगा और एक खुद वो complex रहेगा, right? Yes. Okay. The reaction of X with excess HCl at room temperature results in formation of blue colored complex. Most likely copper है ये, right? Because blue colored complex generally वही पे दिखते हैं. Calculated spin only magnetic moment of X and Z is this negative 0 for complex Y. Among the following, तो कुछ और भी हो सकता है, किसे पता. So what's happening is just CuCl2.6H2O and then you are H. Okay, NH4Cl तो उसमें add करो. Basically like HCl, right? Okay. I think 1:3 electrolyte है, इसमें 3 Cl रहेगा और एक metal complex रहेगा, something like that. Maybe. In that case, just एक तुम इसमें Cl add कर, like CuCl3 dot and then forms an alternated complex synthesis of air. I think इसमें just ammonia to okay, right? CuCl3 NH3 thrice, right? Okay, the reaction with excess HCl at room temperature results in formation of blue colored complex Z. CuCl6, I don't know. The calculated spin only magnetic moment of X and Z is this 3.87. It's like square root of 4 के पास में नहीं? Yeah, sort of 16 or something. 15, right? Yeah. Just, 3 times of 5 or something. Yeah, that's the thing. So तुम्हारे पास n वैल्यू 3, मतलब कि इसमें 3 अनपेयर्ड इलेक्ट्रॉन्स रहने वाले. ओके, 3 अनपेयर्ड इलेक्ट्रॉन्स. It's like MCl3. It's just making no sense now. 6H2O MCl2 CuCl2 काम करता है तो फिर इसमें CO2 प्लस रहेगा नहीं या थ्रू आउट. होपफुली कुछ और हो नहीं रहा है इसमें. So what CO2 plus like minus 26 and cobalt will contribute. Copper, okay, so iron is 8, फिर इसमें 9 10 11 11 माइनस अभी 2 प्लस लाइक इसमें 9 आ जाएगी. 9 D9 है अपना T9 राइट. ओके, इसमें क्या 1 2 3 4 5 1 2 3 4 5 6 7 8 9. तो इसमें एक बचा हुआ बेसिकली इलेक्ट्रॉन राइट. Yeah, and you want this to be 3 or something. Okay, wait, D9 doesn't actually make sense because, right, it doesn't actually make sense. No, it doesn't. तो ये कॉपर नहीं है इन दैट केस. हाँ, तो ये क्या है? आई हैव नो आइडिया. इसमें 3 अपने को चाहिए एटलीस्ट. सो व्हाट डू वी डू इसमें ना सब कर नहीं कर सकते राइट. इसमें 2 प्लस आने वाला है इन एनी केस. सो इसमें 2 प्लस आने फॉर्म्स 3 और समथिंग. व्हेन डज दैट हैपन? So it's cobalt. Okay, it's cobalt basically, right? Okay, cool. कोबाल्ट यहाँ पे 3 आ रहा है. ओके, एंड उसकी क्या है? जस्ट 4 प्लस 6 7. सो कोबाल्ट 7 इज इट. या ओके, डी में तुम्हारे 7 है. सिल्वर 92 आई गेस ओनली 2 इक्विवेलेंट्स ऑफ सिल्वर क्लोराइड. तो बेसिकली क्या हो रहा है? जस्ट लाइक ओके, यस ओके, सो ए इज करेक्ट. इट्स जस्ट Cl3 आएगा ना इसमें. यस, 23 का ए करेक्ट लग रहा है मुझे. और क्या है? द हाइब्रिडेशन ऑफ सेंट्रल एटम sorry central metal ion is D2sp3. अच्छा, Y में right. So Y is when you just have um like just cobalt and then you got Cl3 and NH3 thrice. This is what? It's just cobalt 1 plus, right? Because wait, no, it's make minus. Cobalt, yeah, wait. Cobalt 7 is like okay, so 2 plus है of course, and now it's just negative over there. ठीक है. Then the habitation of central metal ion is D2sp3. ये 3 है, which means and it's like octahedral as well, so D2sp3. No, it's like sp3d2, not D2sp3 because ये right, it's 3, not yeah, that should be the thing. That should be the thing of course. Unless कुछ और ही हो रहा है यहाँ पे. और इसमें कम कर दिए लाइक वो 2 मार डालो. Just get a single of these guys. That would just make DSP3D. That doesn't make sense. Which means कि ये probably ऐसा है. यहाँ पे एक भी just 3 over these. Okay, that's not good. This 2 plus ये है, मतलब इसमें क्या? इसमें 5 चाहिए. काफी कम कर दिया नहीं? Yeah. So it's not cobalt, and what is it? I don't know. ठीक है ना? Z is a tetrahedral complex. Where is Z? Okay. अच्छा, HCl इसमें बना था. Then it gives blue colored complex Z. So अच्छा, tetrahedral. Okay, that's now new. मुझे नहीं पता. Just move on. Just move on. Of course. IBC नियम को तो हो चुका है. So 24 हो गया. I mean, we don't know how to answer this. Methyl. I think I'm gonna go with toluene. Most, yeah, like कभी कभी होता है ना कि वो कॉमन नेम्स जो रहते हैं those also are in IUPAC nomenclature. शायद से B करेक्ट हो. I have no idea. Let's go with it. ये बोलता भी कुछ नहीं तो कुछ अच्छा है. So it's either this thing or it's like 4-methyl chlorobenzene. Oh, well, no, that's not the case. Chlorobenzene. That's not the case. Like either this thing 1-chloro-4-methyl benzene or it's 4-chlorotoluene. Straight 1-methyl 4-chlorobenzene or fluorochlorotoluene. I think B would be the correct thing. Anyway. So this is it. 35. इतने में क्या कर लेंगे. Then this is it. Okay. या पता है मुझे, बस रुक जाओ। चलो फिर चेक करते हैं। फर्स्ट है ए बी डी, मैंने सिर्फ बी डी किया तो मैं इसको खुद को दो करेक्ट दे रहा हूँ। देन नेक्स्ट बी सी, देन नेक्स्ट ए डी, डी नहीं है, दैट्स रॉन्ग फॉर सम रीजन। फिर नेक्स्ट सी, ए बी सी किया मैंने, लेकिन ये कैसे हो रहा है यार। फिफ्थ बी डी इज करेक्ट, सिक्स बी सी, सेवंथ ए सी डी मैंने दो। ओके, दिस इज नॉट गोइंग गुड। एट का सिक्स मैंने सिर्फ थ्री किया, इट्स रॉन्ग। वेट, मेरे इतने सारे गलत कैसे हो रहे हैं फिजिक्स में, दैट डजंट एक्चुअली मेक सेंस। नाइन्थ फाइव मैंने तो बहुत केयर के साथ में प्रॉपरली किया था। 11th 6 है, ये रॉन्ग हो गया। 12 5, 13 का डी, 14 ए, 15 बी, 16 डी, 17 का बी, 18 डी, ओके। 19 ए बी सी, मैंने ए से बी सी का उसको टू करेक्ट किए। 20 का बी डी मैंने वन करेक्ट किया, ओके। 21 ए बी डी मैंने दो करेक्ट किया, ओके। 22 मैंने किया। 23 बी सी डी, और मैंने एक, ओह आई थिंक मैंने इनकरेक्ट जहाँ पे करेक्ट कर डाला होगा। हाँ एक्सपेंसिव, जो भी है। 24 ए बी मैंने एक करेक्ट किया है, सो मुझे वो मिल जाएगा। 25 बी डी मैंने एक करेक्ट किया है। 26 इज टू, दैट्स राइट। 27 6, फिर 28 6 मैंने 19 किया। 19 कैसे हो सकता है, बिकॉज वो तो 09 था, ऐसा स्पेसिफिक उन लोगों ने बोला था। मेरा एक गलत हो गया, इट्स अनएक्सपेक्टेड, जो भी है। 29 29 क्या, क्या मुझे बताओ तो, जब से फुल मार्क्स वेर अवॉर्डेड, ओके सो ये मेरा करेक्ट, मैं अज्यूम करूंगा। ओके, 30 का 5, यस। 31 सी, ओके। 32 का ए, 33 सी, 34 का ए, 35 सी मैंने किया नहीं, ओके whatever। 36 बी, 37 ए बी सी, 36 38 का सी, 39 ए सी डी, अच्छा वो है नहीं, ठीक है, सो ये मैं करेक्ट मान रहा हूँ आपका। 40 बी, मैंने ए बी की जगह दे रखा हाफ, so 1, ठीक है। 41 बी डी, फिर 42 का ए बी, 43 ए बी, yes। Then 44 2, then 2 once again, then 1, then 5 6, then B, 49 का B, yes। 50 का C, 51 D, 52 B, 3 B, 54 C, ओके। सो कितने करेक्ट हुए, एक दो तीन चार, ये टोटल कितने, लाइक 41 to 54 इज जस्ट 13 इज लाइक 14, तो 14 प्लस इसमें कितने करेक्ट हुए, एक दो तीन चार पाँच छः सात आठ नौ 10 11 12 12, ओके। प्लस एक दो तीन चार पाँच छः सात आठ नौ 10 11 12, हाँ मेरे फिजिक्स में दो एक्स्ट्रा इनकरेक्ट हुए, नॉट गुड यार, नॉट गुड, जो भी है। और प्लस, ओके, तो इतने इतने करेक्ट है, विच इज लाइक व्हाट, 26 12, which is like 38, 38 correct, and how many incorrect, एक दो तीन चार पाँच छः बस छः, सो 6 इनकरेक्ट, और पार्शियल मार्किंग, 2 + 2 + 2, 6 + 1 7, 7 + 2 is 9, and plus 2 once again, which is 11, so 12, so plus 12 पार्शियल मार्किंग। ओके, तो इससे मार्किंग स्कीम क्या थी वैसे, जो भी मार्किंग बोली, मैं जस्ट 4 - 1 अज्यूम कर रहा हूँ। टोटल कितने, 54, 54 टाइम्स 4 जो भी आएगा, और यहाँ पे क्या है, 38 टाइम्स 4, फिर -6, बिकॉज 4 - 1 वेट, आई थिंक ये मार्किंग अलग थी ना इनकी, बिकॉज इसमें क्वेश्चंस भी कम थे, तो मे बी, जस्ट मे बी मार्किंग स्कीम इनकी अलग रही होगी। यार मेरे फिजिक्स में इतना सारे गलत कैसे हुए, आई डोंट नो, सारे मल्टीपल चॉइस में गलत हो गए, ऑनेस्टली कैसे हो रहा है। मेरे इंटीजर टाइप में भी दो गलत हुए, इट डजंट मेक सेंस, बिकॉज management with all the care that I could, or still was somehow, ठीक है। सो सेक्शन 1 में क्या है मार्किंग स्कीम? फुल मार्क्स लिए 4, पार्शियल मार्क्स 1 एंड अच्छा नेगेटिव 2। ओह सब में नेगेटिव, ओके नेगेटिव 12 करना पड़ेगा दैट केस। दैट्स काइंड ऑफ नॉट गुड, हार्श या। एंड देन फिर प्लस 12 तो मेरे जो एक्स्ट्रा पार्शियल मार्किंग से हुए वो इनफैक्ट कैंसिल हो जाते हैं। दैट बेसिकली मीन्स कि 30 अपॉन 54 मेरा स्कोर आ रहा है, which is already to 17 upon 27, 17 और 27। अगर इन 27 क्वेश्चन थे मेरे 17 करेक्ट हुए होते बेसिकली, राइट। नॉट अ गुड स्कोर या। तो करो परसेंटेज में कन्वर्ट, वेट अ सेकंड। आई थॉट ये वाली इजी रहेगी, आई मीन है ऑफ कोर्स बट इसमें मेरा कुछ भी। सो 0.629 ओके 0.63 मतलब कि 63%। दैट्स अ बैड स्कोर या। आई थॉट लाइक 70% वगैरह होने वाला है बिकॉज ये इजी है। चलो जो भी है, सी यू नेक्स्ट वीडियो, बाय।